Hello, in today's video we'll build a series analysis system with AI, NLP, and LLMs. We will create two text classifiers, an awesome character network with named entity recognition, and a character chatbot with one of the state-of-the-art LLMs out there. This project is a powerhouse that will beef up your resume with 4 big NLP models, and we'll put those models in a beautiful web UI with Gradio. We will first start by choosing a series to analyze and then crawl its data from the internet using Scrapy. Then we'll go over the basics of neural networks and how they evolve to become those powerful LLMs. After that, we'll extract the main themes of a series with zero-shot classifiers and Hugging Face. In the second module, we'll create a character network that shows how big each character is and plot their relationship with one another using Spacy's NER model. Up next is the most common NLP task in the field, which is training your own text classifier with a custom dataset. Last but not least is a character chatbot where you will be able to have a full conversation with your favorite character. We will train an LLM called Llama, which is one of the best LLMs out there, to imitate the attitude and the personality of your favorite character in the series. Whether you're a beginner or an experienced NLP engineer, this project will boost your NLP skills and take your resume to the next level. Let's start the project. We'll begin by finding a series that we want to analyze. Whatever series we choose, we need to find 3 different types of datasets for them: a subtitles dataset, a transcripts dataset, and a classification dataset. I'm going to show you example datasets on the series that I choose, and then you can find similar datasets on the series that you want. If you're not comfortable with your data wrangling abilities, I recommend you to follow along with the series that I choose, and then you can expand it to the series that you want. I am going to choose the Naruto anime. Naruto takes place in a world that is divided into multiple hidden villages, each of which has its own ninja clans, and some of them are good, some of them are bad, but the main character here is Naruto that is trying to become the best ninja ever. So we can start by creating a new folder that is going to have our code, so you can call it whatever you want, and then inside of it we're going to have another folder that is called data. So just create data that is going to have our own datasets. Then I'm going to paste in a text folder that has the links for the 3 types of dataset that we want. So the first is the subtitles dataset. The second is also a transcripts dataset that we are going to download. And the third one is going to be a dataset that we are going to crawl. And this is going to be the classification dataset. So let's open the first link. Right there. And this is going to be the subtitles datasets for all the episodes in the first season. Just download it. Press on this download button. It's going to finish downloading. Go to your downloads folder, cut it, return back to your data folder, and paste it. And then you can extract it. Or unzip it. Then we can rename this folder, the extracted folder, to subtitles and delete the zip folder. And I want to show you the dataset. So each of those files is going to be an episode. And at the beginning, you're going to find some metadata. But afterwards, you're going to see that at second 5 till second 11.99, this is being said. This is the narration that is being said, or a character that is saying this, and this is the second line where also this is being said, and so on and so forth. You're gonna find that we don't know who's saying this, and this is the difference between the subtitles dataset and the transcripts dataset. The transcripts dataset tells you who's saying this right now. So you can go to the second link and I can show you that. So the second link is going to be from Kaggle, and it's telling you that Naruto, which is the main character, is saying this, and a ninja is saying this, and Iruka is saying this, so on and so forth. The problem with this dataset is that it's not on all the episodes, so that's why I divided it to a subtitles dataset and a transcripts dataset. I'm going to choose the subtitles dataset on the character network and the theme classification, since it's going to be a lot of data, so we can analyze it. And for this smaller data set, I'm going to use it for the chatbot. And yeah, so make sure to sign into Kaggle. It might require you to sign in to download. It's going to be free. And then you can just press download button. Again, go to your downloads folder, cut it, paste it right here. Then we can extract it or unzip it. And then we have an archive folder, just go inside of it, then cut the naruto.csv and paste it outside. Then we can delete the zip folder and the archive folder, just like that. And the third one is going to be a classification dataset. So let's go inside and see that. We are going to crawl this and not download it. So in this dataset, basically, you're going to find a lot of ninja attacks. So there are multiple ninja attacks that are being used in the series. You're going to find a whole list. And then at the bottom, you can actually go through a next page. So there's a next page, and a next page, and a next page, again and again. They are a lot of ninja attacks. And the ninja attacks is divided into multiple categories. So one category is going to be a physical attack. So I'm going to show you this. So if you clicked on one attack like this, if you clicked on any attack, like the 10-hit combo, you're going to find its title, then its description, and then its classification. This classification basically tells you what type of ninja attack is this. So we are going to have three types of ninja attack, which is ninjutsu, genjutsu, and taijutsu. So I'm going to show you it. So taijutsu is going to be any physical attack that is normal, like kicking or punching, things like that. Ninjutsu is going to be somehow of a magical attack where the use of fire, wind, or something called chakra is in place. And this is going to be something called ninjutsu. It also hurts you physically, basically. And genjutsu is what hits you like in your senses, which is sight, hearing, or like mind games. So those are the three different types of attacks that we want to classify. So back again here, you're going to find that this is taijutsu. So this is just a physical attack. And what we want to do is that we want to loop over each link. Then we want to extract the title, the description, and the classification, and then put it into a structured data set. And after looping on all this in page 1, we want to actually loop in page 2, 3, 4, and so on and so forth. So to do this, we are going to use something called scraping data from the internet. And this is a very important skill when, in the world of NLP, since a lot of NLP data sets are actually crawled. And this becomes a requirement in the CV. So it's quite good to have it in your tool belt. And since we're going to be crawling like from a website, I'm going to onboard you or like give you a recap on the main building blocks of HTML so that you understand what you're crawling and you understand the code that you're writing. So you can go back again to your folder, like here, and I am going to open up a terminal. And from here, I am going to open up Visual Studio Code. You can choose whatever editor you want, but I'm choosing here Visual Studio Code. So let's onboard you a little bit on the HTML components. And if you're comfortable with your HTML, then feel free to skip this section. But it's going to be a very quick recap. So maybe if you stayed along, you can just have a quick recap on it. So this is an HTML page. That is going to have .html extension. And the first thing that we are going to do is that we are going to have a doc type HTML to specify that this is an HTML page. and then have something called HTML to indicate that this is the beginning of the HTML code. Now in HTML, things are in tags, basically like this, an opening tag and a closing tag. And whatever data that is inside, it's going to be within this tag. So we can start by having a header tag. And this header is going to be just having the title of the page. And then we can have a body tag that is going to have the body of the page. And we can have a huge heading tag that is called h1. And just like the Word document, like header 1 is going to be a big text that is going to be bold. And we can write welcome to my page. Then you can go back here, open up the example HTML, and you're going to find the h1 tag right there. So the HTML page is being rendered by the browser, and you can see how it looks. So basically those tags is a way to tell the browser how to display those tags, and this is just HTML, it's just markup language. We're marking up the text or the components inside of it to tell the browser how to display it. We can also have something called a paragraph tag, which is just normal text. So this is a sample HTML page. Just save it, don't forget to do so. Go back to your link and refresh it, and you're going to find that this is the paragraph tag that we have. And then we also have something that is links like this. This is a link that if we clicked on it, it takes you to another page. And to do this in HTML, we have something called an anchor tag. So an anchor tag takes in an attribute which is called href, that is just a link that is going to be redirected once you click on the text. So we can just write Google, like the link of Google, and you can write whatever text you want here. So basically we can write Google link, and then you can close it and open it back here, refresh it, and you're going to find the link for Google. Just click on it and it will take you to Google. Then we also have something called an unordered list. And this is just some bullet points that we can add, and we can have list item, which is one bullet point, and this is the first one, second one, and third one. This is li, and this is unordered list. If you go back again here, refresh it, you're gonna find that it has item 1, item 2, and item 3. And the last component that we are going to learn is something called a div, like that. And the div here is just a code container that is going to house some more HTML code, but it's going to be easier for us to say the code inside this div, give it this specific styling or give it this specific functionality. So it's just a way to make our code easier and to refer to specific parts of the HTML page that we want to add functionality on, and we want to add HTML like styling on. So we can just write here h2, which is another header that is less in size, and just write first div, like this, div. Then we can also add a paragraph tag, and this is the contents of the first div. Save it, go back again here, and just see it, and you can see that it just looks very similar to the one without the div. And again, the div by itself does not do anything, it just puts it in a structured container so that the code is organized. We can have another div like this, we are going to have the text is going to be second div. This is the second div in the paragraph tag, and you can see here it's just there's quite similar, but we can add some styling to a div, and this is what I'm going to refer to. A div is just like something that is easier for us to refer. So we can give it a class, which is a way to say this is the div that I am referring to. And you can write container. You can write whatever you want here. And then we can add some styling to it. So to add some styling, we can go back again to the head, write style, then write dot container, which is dot is for classes, then container is the name that we gave down in the div right there. And we can say the text align is center. So we are going to align all the things that inside of this div centered. And this is the beauty of a div. It's like we're referring it, and anything that is inside of it is going to it's going to have the styling that we add. So if you refresh it, you're going to find that the first div here is centered. We're going to also give the class to the other one, which is maybe container2. Go back again up, say container2, and give it a color of red. So you can go here and refresh, and you're going to find that this is red and this is centered. So we are referring to divs by the way that we want. And this, by the way, in the style section, this is called CSS. We are not going to cover it. I'm just letting you know what the divs are for. And those are called like CSS classes that we can refer to. Then we can have another div, which is a third div. And we can have also an h2 tag and a paragraph tag like this. Right, third div and this third div like that. And let's refresh it and see how it looks right now. So that's how it looks. And in the class, like that, you can give it two classes. So you can give it container1 and container2. So the stylings from this and this is going to be applied both. So it's going to be centered and red. So one div can have multiple classes. So if you can go back here and refresh it, you're going to find that it is centered and red, like that. And this is our HTML recap or quick crash course. And we are going to use this knowledge for our scraping. So you can close this. And you can close every other thing. Like I had this folder before. That's why I have different other unopened folders. But you shouldn't see it. Now, in order for us to crawl a website, we need to use a crawling library. A very famous library is called Scrapy, and it allows you to scrape data from websites and quite easily. And the first thing that we are going to do, we are going to just pip install it. So you can go back here, make sure to pip install Scrapy like that, and then press enter. It didn't take a long time from my end because I already have it, but it should take a little bit of time from you. Then you can clear the output like this, and we can go over this code together. So the first thing we are going to do is we are going to create a folder called crawler. Inside of it, create a file called whatever you want, but I am going to call it Jutsu crawler, since we are going to be crawling jutsus. And jutsus is just the ninja attacks. It's called jutsu in the Naruto anime. And you can go back here, copy the boilerplate code, and paste it right in. So let me explain to you what this code is all about. So it's first imports Scrapy. Then it creates a class called blockSpider. We can call it whatever we want. It inherits from Scrapy.spider. And Spider is just a crawler that crawls multiple web pages. And it has the ability to traverse through web pages. So this is called the Spider. And this class has all the functionality that is needed to crawl the data and put it into a structured dataset. It first makes the name, it initializes a name. Also, you can call the blockSpider whatever you want. You can give it whatever name you want. And then it takes in a starting URL. Our starting URL is going to be the main page that have all the jutsus listed like this. And yeah, so you can choose, when you're choosing it, like you choose the page that you can iterate through them quite easily. And yeah, it has all the things that you want to crawl. Then it has a function called parse that has two for loops, like this and like this. The second for loop is the one that is iterating over pages. So it is iterating over this, going to the next page, the next page, the next page. And the first one is iterating through the objects that we are trying to crawl. So it's iterating over this, 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 and this. So it's iterating over each jutsu that we have. Of course, right now, this is not adapted to our code, or this is not adapted to our website, but it's like this is some boilerplate code. So you can find that it is looping over each title in the response, and the response here is just the web page. .css is actually filtering out the HTML page to anything that has the class of Oxy post title. So it's using the class again, like those classes right there. So that's how we are referring to the things that we are crawling. And then it tells it, get me everything that has this class. It loops over them. It takes in the title and extracts the text and put it into a structured variable, which is a dictionary that has a title and then the value of the title. And yeah, this is the explanation of the boilerplate code, and we can now start adapting it. So we can write Naruto spider in the name. You can go here, copy the URL, and put the URL in the starting URLs. And then we want to know which like what CSS class is in this link, which is the link that is that goes to the next page, and you just press right click, inspect. Then you have this tool right there, and you just highlight the next page. And if you highlight it, basically you're going to find that it is an anchor tag right there. With an href, and it also has a class of MW next link. So you can copy it like this and paste it right in. And this is how you are iterating over next pages. So it is iterating over the anchor tags, and it is calling the parse function again on it. So it's going to parse the data and then go to the next page. Right now, we are not like extracting the data that we want. So what we want to do is we want to have a for loop that opens every link of those. So we are going to make another request to get this page, and then extract this, and the classification as well. So you can go back here, and you can also choose the tool. And you can see, like you can start to highlight on the place that you want. And you can see that in this div that is called SMW column list container, it has a column So every column like this, and you can see the highlighted version in the page. So this column has a lot of that is going to have links, anchor tags, and it has a second column and a third column. And then if you open the column like this, you are going to find an unordered list, each of which has its own LI, which is list item, that is going to have an anchor tag. And if you see the href right there, it has /wiki and 10-hit combo. And if you clicked on it, you can see that it appended the narutofandom.com link before the /wiki 10-hit combo. And yeah, a better, like, we can loop over every anchor tag in the SMW column list container, and like you can see, we only have one tag in the page, one div with that class in the page. So you just can copy it and paste it right here. Now this is the div. Then we know that it is going to be only one div, so we can write .0. Then inside of this div, we want to get every anchor tag, and we want to extract the href attribute of it. So you can write attribute and write href like this, then extract at the end. And right now we are not extracting titles anymore, we are extracting hrefs. And what we needed to do is that we needed to follow this website, we needed to follow the link and go to the other page, like this 10-hit combo, and then start crawling. So we can have Scrapy dot request, which is making another request to the narutofandom.com / then the href. So we are going to have this plus href like that, and then we can have a function to call when we have this request. And let's call this function parse jutsu, that takes in the HTML page that of the hit of the ninja attack, and then we can start and crawl the relevant information that we want. So the output of parse jutsu is going to be a dictionary. I'm going to have it as a dictionary. So we can write extracted data, and this is a dictionary, so we can just replace it by this. Now all what's left is that we want to write the parse jutsu function. So let's create it. So create parse jutsu, and you can like delete the suggestion. Those suggestions are from GitHub Copilot. So yeah, if you're just wondering what it is, so yeah, basically it's not that accurate because I wrote this code before. Maybe it just memorized it, so it just has a little bit of like a hint of what I'm going to write. But yeah, because I wrote this code before in the preparation for this tutorial, so GitHub Copilot is a bit smarter than usual. So yeah, so the first thing we want to do here is that we want to extract this title. So you can go back again, right click, inspect. Again, I'm using Chrome here, so you're gonna find it in Firefox and you're gonna find it in other things, but it might have a different look. So yeah, so just highlight the title. So if you highlight the title, you can find that it's a span that has a class of MW page title main, and we just want to have the text of it. So just copy the class name, go back here, and then write jutsu name, response. This is the response, which is the page. Then we can say that we want to have a CSS selector that is going to choose a span that is going to have this class name. And what we want from this span is that we want some text, the text of it, and we want to extract it and only get the zeroth element because there is only one of it, so no need for the list. And don't forget to put a dot here, so it's dot extract. Now, some jutsu names might come with trailing spaces and some spaces at the end. So in order to remove it, we just write jutsu name.strip, and this strips it from any leading or trailing spaces. Now, the next step is going to find the this. We want to extract this, and we want to extract the classification as well. The hard part here is that both are in the same div. So you're going to find MW parse output is the main div that has both, and we want to extract this classification, and we want to extract this without this trivia section. So let's first get the contents of this div, and then we can find ways to extract this relevant data. So let's call div selector. It's going to be response.css, and it's going to be div, and we are going to give it what class we choose. So it's going to be MW parse output class. And because it's also one div in a page, so we can just write off 0. Then let's extract the HTML of this div. So we can have div HTML equal div selector dot extract, and this extracts the HTML of the selector that we have. Now, in order for us to choose and to filter out the HTML efficiently, we want to use a library called Beautiful Soup. So you can just come here, just write pip install Beautiful Soup to get the Beautiful Soup pip install function. Just copy it, paste it right here, then press enter, and it should install the Beautiful Soup. I'm not going to do it, I already have it, but install it if you don't. And let's import it. So from BS4, which is Beautiful Soup, import Beautiful Soup. And we can initialize a Beautiful Soup object by just writing soup equal Beautiful Soup, then give it the div HTML, like that, and write find div. And this gets it the first div that it has in this HTML. So let's return back to the page right here, and let's see what this is. So this is called an aside section, and it is another HTML component. And in this aside section, we have sections like this. So this section, this section, this section. And inside of the sections, you can find divs also, where each row right here is going to be a div on its own. And in this div, it's going to have an h2 that is going to be this, which is the name of the attribute and then the attribute itself. So an h2, and then another div, going to be, it's going to be an h3, and then it's going to have another div with the value of it. So the h2 one was the title of the section. So let's try and first get the aside section, and then get the div or the h2 that have the classification class, the classification text, this one. So you're going to find that it's h3. So it's h3, and then we want to get the div inside of it. So we loop over the divs that are rows, and then choose the one that has the h3 that has classification. And if that is the case, we are going to take in the classification here of the div. Note that when I'm highlighting things in the HTML, it's also highlighting here. So so make sure to look at the highlighted text. It might help you understand things a little bit better. So right now, let's get this aside section. So if soup.find aside, so if there is an aside section, then we are going to process it. If not, then we are going to skip it, because there is no classification for this jutsu, so just skip it. Write aside, which is going to have soup.find aside, and this extracts the aside section. And then we want to loop over each row. So let's loop over each row, and like we said, each row here is going to be a div, and this div has a lot of classes. So let's choose the PyData class, like that. So let's have for cell in aside dot find all, and then tell it what do you want to find. We want to find a div with a class of PyData, and then we only want to take in the div that has an h3 that is called classification. So if the cell dot find h3, so if there is an h3, then we are going to start processing it and getting the cell name. So cell name equals cell dot find h3, and then we want to get the text, and then we want to strip it. And then if this cell name is equal to classification, then we want to get the value of the preceding div, which is going to be this one. So right now we're looping over each row, we're calling it a cell, and then we can get the jutsu type, then do jutsu. So it's jutsu type is equal to cell dot find, and then write div. And since we are in the same cell that is in the classification, then this is the correct div that we are having. Then write dot text to extract the text, and then strip it. And in order for us to choose a jutsu type, like to get the jutsu type outside of this if statement, just initialize this jutsu type at the beginning with an empty string, like that. And right now we just got the jutsu type, like this jutsu type classification. Right now we got it. Now the last thing that we want to do is that we want to get the description. Again, it's in the big div, so we want to remove this aside section, and then we want to remove this trivia section. So let's do that. We can go back again here, write something that is called soup dot find aside. So we are going to find the aside and then decompose it. Decompose it is just going to remove it. And then we are going to have the jutsu description ready for us. So we just have the soup and then get the text and then strip it. But we also have this trivia section. And since there is no div for the specific trivia section, then we are going to just try and remove everything before trivia. So write jutsu description dot split, write trivia like that, which is this trivia. So we are going to get the trivia, the trivia word, and we are going to get everything that is before it, so dot of 0, and then strip it basically. And yeah, this is the jutsu description right there. We got also the jutsu name, and we got also the jutsu type. So let's just return back the results. We can return it in a dict where jutsu name, here jutsu name is equal to the jutsu name that we extracted. Then jutsu type is equal to the jutsu type that we also extracted. Then jutsu description is equal to the jutsu description that we extracted. And yeah, this is going to loop over get the extracted data, return it back as a dictionary, and then you're going to find that it is saving the output into a JSON-L file so that we can refer to it. So in order for us to run this, you can go back again here to Scrapy, and you can see that it runs by Scrapy, run spider, then give it the py.py file. And we want to also specify the output path so that we can just put it into the data folder. So just write Scrapy to run this file. Just run Scrapy, run spider, then give it the path of the .py file that we wrote, and then write .o that specifies the output path. Then go to the data. We are going to save it in the data folder. And I'm going to save it as jutsus.jsonl. Like that. Then press enter. I have misspelled spider. I have an R in the wrong place. So you can just press the upward arrow, remove this extra R, then run it. And it might take a while for it to finish running. So just wait a little bit for it and it should be finished. So it's finished now, and you can go back to the data. You can refresh your folders right there, and you can find jutsus.jsonl. This is a list of JSON objects, and yeah, you can find a jutsu name right here, a jutsu type, so a jutsu name, a jutsu type, and a jutsu description. And you can also find the 10-hit combo that we were having. So a 10-hit combo, then tai jutsu, then the jutsu description. And you can see that it parsed a lot of jutsus. So specifically, it crawled 2,920. So it's a fast way to get your own data set and to have it ready for you and into the structured format that you need. And yeah, so right now you knew how to crawl websites, you knew about HTML, you knew about Scrapy and how it works. So this is going to be very beneficial for your CV and resume. And yeah, and since we have our data set ready, now we are ready to get our hands dirty with AI and LLMs. And Yeah, before we start with that, I am just going to onboard you a little bit on neural networks and AI and what is NLP and how did the state-of-the-art models like ChatGPT and Llama, how are they using transformers and how did the research world develop from basic neural networks to the state-of-the-art transformer models. So transformer models are just the models that are used by the state-of-the-art models like ChatGPT and Llama, like I mentioned. And if you don't know anything about neural networks, this is going to help you understand what you're coding a little bit. And if you have some background in AI and NLP, then feel free to skip this section. But it's going to be a very quick recap about the neural networks and NLP and how they even evolved from just feed-forward neural networks to the transformer models. And this evolution, I'm going to show you the evolution of neural networks in natural language processing. So if you know also AI, I encourage you to stay a little bit so that you can know the evolution of NLP from feed-forward neural networks to RNNs to transformers, and this will make you a better candidate in the interview process so that you can talk more about those models. So any AI or neural network starts off with a data set to learn from, and right here we have a very simple data set that is depending on the weight and height as input. We are going to predict whether this is a cat or a dog. So we can just plot this data out. For example, in the 9.6 as weight and 22.2 as height. So you can go like 9.6, then 22 as height. Then instead of just putting a dot, I put a cat to indicate that this is a cat. I can go on, so on and so forth, to put all those data sets here. Now, this is what's called a classification data set, where the input, depending on the input, the AI or the neural network is predicting a defined set of classes, like cat or a dog. And if you give it a rhinoceros, for example, it will also predict a cat or a dog. It doesn't have the ability to classify anything else. So the neural network, we can give it a new sample like this circle and basically tell it, is this a cat or a dog? So we have the weight and the height, but we don't know whether this is a cat or a dog. Again, this is a very simple data set, but you can imagine having it on more complex problems. So as human beings, we can say this circle is closest to the dogs, and so it's basically with a good probability it's going to be a dog. So we can say that I am going to just put a line right there and say anything above the line is called a dog and anything below the line is considered a cat. And this line is just like represented by the simple line equation, which is y equal mx plus b, where m is the slope, x is the x value, and b is the y-intercept. And we can have something similar in this use case where we have w1 times height plus w2 times weight plus b, which is the y-intercept. And w1 and w2, we can calculate them as human beings, but in more complex problems, we actually can't. And this problem is 2D, so only weight and height. But you can imagine having an image with thousands and thousands of pixels or a natural language processing with a lot of words. So this becomes very complex very fast. So we can't reliably do this. And in order for the neural network to know what is the optimal W1 and W2, it needs to start off randomly. And when starting off randomly, it does errors. So we said anything that is above the line is considered a dog. And you can see that those two dogs are misclassified. And those three cats are also misclassified as dogs. So this is the error. But what's beautiful is that through statistics, it can calculate this error, and then it can take one step into the right direction to decrease this error. So you can see that it adjusted itself so that this cat is now correctly classified. This is what we call training. Training is the process of having a forward propagation where we predict cats or dogs. Then we have something called backward propagation where we calculate the loss, then try and take the next step into making this model a little bit better. Now, not all the data fits into memory. Some data sets are millions and millions of rows. So we divide them into batches. So we say, for example, take those 2 dogs and take those 2 cats and those 2 dogs, train on them, and then adjust the model, train on the model and learn from it, and then take another 2 cats and another 2 dogs. And this is batches. So we batch the data set up into multiple clusters, and then we can train from them. And when we loop over the whole data set, when we loop over the whole batches, we do something called an epoch. And we might have multiple epochs, and so we can learn from one data sample multiple times. And after it finishes, it just gets the optimal model. We get the weights. So the weights here are just W1 and W2 and B, which is the optimal parameters to make this neural network has its minimal loss. Now, we can represent this neural network in a different way other than the equation by having this way of representing a neural network. It's more popular. First, we have the input nodes, weight, height, and 1 as for the bias or the y-intercept. So you can find that this is just the height number and this is the weight number. We multiply it by W2, W1, and B. So we multiply B times 1, W2 times W1 times height, and W2 times weight. Then they meet in this output node, and we do whatever this output node does. So right now it's just summing. So it sums up all those factors together to give us the Y. Now this neural network only has 2 layers, the input layer and the output layer. But more complex neural networks has more layers like that. And this is just a three-layer neural network where this is the input layer. And this is just going to be an in-between layer that is called a hidden layer. Right now we have more weights, like you see. It's not just only 3. And each one is going to have a direction to the node. So those nodes have something called a ReLU function, which is a nonlinear activation function, so that we are not only limited to have straight lines. We can have curves right now. We can have more complex neural networks. And yeah, afterwards we have the output layer that is going to also have a sigmoid activation function, which is going to limit the output between 0 to 0.5. So we can easily say from 0 to 0.5 is cat, and from 0.5 to 1 is dog, for example. And the more layers that we have, the more complex problems that we can solve, and the more weights that we have, also the more complicated the neural network becomes, and the more complicated the problems that it can solve. Now, let's switch to NLP. So NLP basically is some text, and from this text, let's also say that we want to classify. So let's say that this is a comment, and from this comment, this video is awesome, and then it classifies it as toxic or non-toxic. So it's also a classification problem, but the problem here is that the input now is text. And you can see from here that those are just mathematical functions, like the forward propagation and the backward propagation. And how are we going to input those words into those mathematical functions? So we are going to divide a sentence into words or subwords that we are going to call tokens. and each of which are going to be assigned a number. So this number is just a lookup table that says video is 36, is 125. It's just a big dictionary that assigns each word or subword to a number. Then we take those numbers in and put it again into as input as a neural network into the neural network, and it was able to understand whether this comment is toxic or non-toxic, like it was able to understand whether this is a cat or a dog. Now, the problem with this neural network architecture is that you can see it only takes in 4 words, and or like we call it 4 tokens. A natural language input and sentences may vary in size. A comment can be just 1 word, or it can be 100 words. So we don't know actually how many words the input should be. So that's why researchers have defined something called an RNN, a recurrent neural network, that takes in just 1 word as input, but we have the ability to scroll through the words one by one. So we can do forward propagation words one by one, while it has the ability to remember what the previous words were. So we can input like 42, which was the word this, and it outputs 2 things, which is the output and the hidden layer or the hidden state. This hidden state is just the memory of the previous words. So you can run in 42, and then you can scroll through to 36, and 36 is going to have like the word 36 is going to have this is the next input, but it also takes in the previous hidden state as input so that it can remember what the previous words were, and then it can scroll through the all the words so that it can output at the end. And this is an unfolded version of the same neural network. Again, this is the same model. So this is what time is it, and you can see that it takes in the word what, then at time it takes in the hidden state, and it takes in time to produce the next state, and at every state it outputs an output, but we can ignore this output and only take it into the last, like from the last word. Now what's limiting here is that this RNN is going to limit us into the number of weights that it uses, because we are using the same weights for every word. So for every word we are using a limited set of weights that we are having, and this neural network is becoming harder and harder to train. It has problems like exploding gradients and vanishing gradients, which basically means that the learning steps are becoming too small or too large for the neural network to learn anything. And that's why people have actually went to create the state-of-the-art model that is called transformers. So let's see how this is done. I am going to use a tutorial by Jalmar to explain this. He have very good visualizations for it, so I'm going to be utilizing them. So Jalmar starts off by explaining neural machine translation, which is translating words from one language to another. Like this is translating from French to English, and an encoder is just an RNN, like the one that we had, and we are going to take its last hidden state and put it to the decoder, which is just another RNN, but it takes in the hidden state of the encoder as the first input. And that is just the difference of it. So you can see the visualization right here. So je has been feed forwarded to the encoder, then it has the first hidden state, then the hidden state of 1 and the second word, which is suis, come together to produce the second one, and then we have the third hidden state, and this hidden state is the input of the decoder so that it can output the I am a student, which is the translation of the French sentence. You can see that this is 4 words as output, and the input were only 3 words, so it doesn't have to be the same amount of words. And you can also see it as an unfolded version. So encoder at hidden 2, then output, then this encoder is going to the decoder, and then it's going to have the I am a student. Now this was working fine with a moderate amount of accuracy, but in order for us to increase the accuracy, we needed to add something for attention, because when the sentences become longer, the decoder RNN starts to forget what it's trying to translate. So we need to have something called attention, which is a couple more weights to the model. So instead of having the last hidden state only fed to the decoder, we are now trying to feed the whole all the hidden states together into the RNN. But in order for us to do that, we will need to also tell the model which hidden states to focus on. So this is what we have as attention. So we take in all the hidden states from the input, from the RNN encoder. Then we have just a set of weights that can score those hidden states together. Then it sums those hidden states, and it has at the end the attention vector. So let's see it from here. So this is the whole 3 hidden states. They are multiplied by a set of weights. You can see it right here. Then they are summed together. Then they are added into the input, into the hidden state, and then there is the output of it. And if you can see, the attention for the second word is going to mainly focus on the second attention place. Now it doesn't need to attend to it incrementally like it's doing it right now. Like I said, number of words as input is not going to be the same number of words as the output. So we need to have the neural network pick and choose what it's attending to. So that's why we have a set of weights that is actually choosing it, and we're not just having an index that it's choosing the height, like the hidden state that we want. Now, this was having an increased performance on that, but after that, Google has released a paper called Attention is All You Need. So basically, it's going to take in the attention and throw away the RNN. So here you can see the input, and it's going to be fed forward to a multi-head attention without the RNN. Now, losing the RNN here means that we lost the ability for it to run on varying sizes, and this is not a big issue since the transformer model takes in a minimum of 512 tokens, and the new ones takes in thousands and thousands of tokens. So in most use cases, you won't be able to surpass that, and this is going to be more than enough for you. But the accuracy gain here is a lot, and it's worth having this trade-off. But what if we want to have a number of input that is less than 512, or the maximum number that the transformer can have? We just have a padding token. So look at this example. My dog is cute, and then the rest of the input is just a padding token. A padding token just tells the model to ignore this output and to ignore this in the training so that it doesn't get confused. You can see that we have also something called a CLS token, and this is just called the start token. So this indicates the start of a sentence. And we also have a separator token, which indicates the end of a sentence. Now, how is this model trained? How does it know language, and how does it actually understand the different fields that it can answer to? So if you ask ChatGPT about anything, it's going to have an answer about it. So what we do is that we have something called semi-supervised learning, where we give it just any text from the internet, and we randomly mask 15% of the tokens. So this is an example right here. That is a sentence. The original one is let's stick to this improvisation in this kit, and it masked the word improvisation. So right now as input, the model doesn't see it. And then we ask the model to output the word improvisation so that now it can understand language. And you can also think about it as also understanding different concepts. So let's take an example from a biology class, for example. And this sentence is called, "The heart pumps blood to the body." And let's say the mask has is on the heart. So the then mask pumps blood to the body. Then the neural network must understand that the heart must needs to pump blood to the body. So it now has a biology information in it. So by this, it can gather a lot of data. It can understand it. It can store it, and it can understand a lot of language as well. Now, the last thing that I want to show you is that the transformers enabled us to actually reuse it. So big companies use a lot of data with millions and millions of rows and spend a lot of money training those models with big GPUs. And then we can reuse those models for our use case and then train it to have classification and things like that. So if you want to know how classification is done using transformers, we usually take a trained transformer and then fine-tune it, which is basically training an already trained model on a specific task. And then we can input this sentence. You can imagine it as having as the sentence that we have for the comment. So you can enter the comments right here. Then we take the output of the CLS token. So the output of the star token, we can put it right here, and you can feed forward it to a neural network normally, which is the one that we have right here. So we take the output of the CLS token, we output it right here, and the neural network is going to learn through backward propagation normally. So this is what neural networks are and what NLP is. And I already also told you how the big models like ChatGPT and Llama are made. What is the underlying neural network that it uses? So this is a lot of good information for you in the interviews, and it's also going to help you also understand what you're coding. And I think we can start on by coding up our theme classifier. So now we can move forward to our first module, which is theme classification. So you're going to input some themes that is comma separated, like friendship, hope, sacrifice, battle, self-development, whatever you want here, but make sure that they are comma separated. And then it will tell you how much of each theme is occurring in this anime using the subtitles. So this is the first module that we are going to make. And for this module, we are going to use something called zero-shot classification. Now, for the normal classification, we knew that the neural network needs to have a defined set of classes in order for it to classify output. But you can see here in the zero-shot classifier, we can input any arbitrary number of classes and anything that we want. So, anything like we want. So, my themes doesn't need to be your themes, doesn't need to be anyone else's themes. So, in order for us to do that, we need to do something called zero-shot classifiers. Now, this is a special type of classification that is called zero-shot classifiers. And in the zero-shot classifiers, we take in two inputs. The premise, which is the text, like I love this product, this is an example. the hypothesis, which is the class, that is going to be positive feedback. So we are classifying whether this is a positive feedback or not. And the output is going to be 3 distinct classes, which is entailment and contradiction. So this contradicts the class. Entailment, that this is actually the class, and neutral, that this is something in between. So the neural network at the end is outputting 3 classes, but we were smart enough to put the class in the input so that we can have as much classes as we want. Now, this is the zero-shot classifiers, and we are going to use something called Hugging Face, which is a library that have a lot of transformer models that we can use and utilize to do a lot of NLP and LLM tasks. So we can go back again to our code base and create a new folder. Let's call this theme classifier. And inside of the theme classifier, I am going to create a notebook class, a notebook file, so that you can follow along and you can understand what's happening. And then we can move this code to the .py file so that we can have it in a structured format. So let's create a new file. Let's call it theme classification development.ipymb. Then you can run, and it will tell you to choose a Python environment. Just choose the one that you want. And then we need to install transformers. So for that, we can create a new file that will have all our requirements so that we can have our requirements in one place. So you can have requirements.txt. And we can go ahead and run and write transformers and equal 0.43.3. And this is the exact version. Sorry about that. It's 4.44.0. This is the exact version that I'm using. And you can go back again to your Google and write pip install transformers. So you can understand that you need to copy this and put it right here if you didn't write it, and you can write whatever version that you like. This is the version that I used so that you can replicate the results that I'm having. I am also having something called Hugging Face Hub, and this allows you to push models to the internet, to the Hugging Face, and you can download it. And the exact version that I'm using is 0.24.5. And in order for you to install the requirements, just pip install -r, then write requirements.txt like this. So I'm going to stop it. I already have those. So yeah, you can go back again here and you can install the Hugging Face, and you can import it by having from transformers import pipeline. Now, transformers is the name of the Hugging Face library that I was telling you about. And yeah, we are also going to use NLTK, which is another NLP library. So you can install it by writing NLTK and equal 3.8.1. And yeah, don't forget to pip install your -r requirements like this, so that you can install the NLTK library as well. And you can come here and you can also import it. So from NLTK import, and what we want to import is a sentence tokenizer to like separate sentences, separate text into multiple sentences. And yeah, we also want to install a library in NLTK. So NLTK.download and download punct. Make sure to import it first. So import NLTK and make sure to download it. Now let's first load the model, load the theme classifier model, and tell you how it works. So we can write a section called load model. And then we can go to Hugging Face. So you can go to Hugging Face right here, and you can find a lot of models on the Hugging Face hub, like this. And those are all models like here. So you have models in computer vision, you have models in natural language, you have models in audio. And what we are going to do is that we are wanting to have a model in zero-shot classification. It's also known as neural natural inference. And so you can have Facebook /BART large and MNLI. So yeah. So this is the model that we are going to use. It's from Facebook. It's called BART. So just like BERT that I showed you before, BART is another Transformers model. Large, we have large, medium, and small. And large has the highest accuracy, but of course it consumes the largest amount of RAM. And the MNLI, which is a multi-natural language inference model. Just another name for zero-shot classification. So you can go back here and write model name equal and paste in the Facebook part. You can just copy it from here and paste it. Then we can set the device, whether we are using a GPU or a CPU. I don't have a GPU on this machine, so I'm using a GPU. And I am using a Torch. So basically, Torch can be like, it will be installed with Transformers, so you can just import it. So import Torch and say 0 if torch.CUDA is available, else then I am going to put CPU. So it will choose the 0th GPU, which is GPU number 1. And else I am going to use a CPU. And like I said, I am using a CPU right here. So you're going to find that the CPU device is being set. Now let's create a function to load the model. So it's define load model, give it a device, which is the device that we want. And then we can have theme classifier equal to pipeline, which is the Transformers pipeline right there. Give it the task that you want to have, which is zero-shot classification. Then give it the model name, like that. Then give it the device. And just return the theme classifier. Now note that I am like reading the model name from a global variable. Because I am going to have this into a class, so I'm going to refer it to self dot something like this. So I'm just leaving it like this, but it is not like good guidelines to have it read from a global variable like this. We can then call this class, so have theme classifier equal load model. Wait a little bit for it to install the model and put it into memory. And then we can have a theme list, whatever list we want, like the themes that we want to classify. We can have it here. You can go back again to your visualization and GUI, and you can go here and paste them. So make sure to have them in a list of strings. I am just making it with quotes like that. And this is the list of themes that we are going to have. And in order for me to classify anything with the zero-shot classifier, you can just call it like this. So theme classification, then write the text that you want to classify. So I gave him a right hook, then a left jab. This is basically like a fight scene, like a fight text. So I wanted to have like a battle theme. So you can also give it the theme list like this. And you can say that it is able to have multi-labels, so it can be battle, and at the same time it can be self-development and things like that. So you can run it, and you can see the output right here. So it has the label of battle with 0.9% confidence, and the maximum confidence is 1. And you can see that it has also self-development and more so on and so forth. So this is the output that we have. Now the next step in our exploration would be loading the data. So just write load data set like this. And we are going to be loading the subtitles dataset, which is this one. So this has multiple files and folders, actually only files. So just write from glob import glob, and glob helps us to get all the file path that we want. So just write files equal glob, and inside of glob, go back one folder, write data, which is this one, this data. Then have the subtitles folder like that here. Then say that we want to get all the files that we want using the star that end with ASS, because the subtitles end with ASS, so that is what we want. And just run it, and maybe just show the first 5. So you can find that those are the files that we want right here. And we're going to loop over them one by one and open them and get the data that we want. So with open files of 0, let's open the first one. And this is opening a file. And then we can read the lines of this by files.read lines. And let's open the subtitles again together. So we have a couple of metadata at the top till line 27. So what we want to do is that we want to remove all this and keep everything underneath line 27. So we can have this by writing lines of 27, so start from 27 till the end. And then we can see here that every line after this is has multiple commas. So it begins with the format, then it has the start, comma, then start, comma, then end, comma, then style. But at the end of the day, we just want the text. And note that the text might have a comma also. So what we will do is that we will split by the comma and remove everything that is before this comma basically. And this is the ninth comma. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. So till the 9 comma, we will remove everything that is before that. So let's do that here. So I am going to do a one-line for loop. And if that confuses you, feel free to separate it out. But you can write for, like this, for line in lines. And now, in this line, you can just write line dot split with the comma. Then we want to remove the first 9 commas and then take everything afterwards. And after this, we just want to join it again using a comma. So this is going to return a list of sentences. And after this, we are going to combine this list of sentences with a comma, like that. So you can run this. Yeah, I forgot to write dot join, like that. we need to have it dot join. And yeah, you can have lines of, for example, the first two, and those are the first two lines that we have. A long time ago, then the comma right here, a powerful demon, then this is the second line, so on and so forth. You can see we have a weird // in this place, so we can clean this by removing it. So lines equal for line in lines, and then line dot replace, we are going to replace the / n like this with a space. And let's display again the first two, and you can see the / n is now removed. Now we can combine different sentences together into one big paragraph. So let's do that. So we can write, like, let's join them with a space. So join lines of the first 10, and it will be joined together in one sentence. This list will be joined again in one sentence, and it is separated by a space. Now, this is the text that we are going to feed forward to the neural network, to the theme classifier. And since the theme classifier has a maximum of 512 tokens, we cannot feed forward the whole subtitles. So we need to divide them into batches of 10 or 20 or whatever, so that it just can fit into the model. And then we can run it one by one. Now, what we also want is we want to also extract the episode number. So we can do that by getting it from the file name or file path. So files of 0, this is it, and we can just get the last bit, which is split. And we are going to split by this so that we can get everything that is afterwards. So split by that and do a -1 so that we can get the last one. Then we want to split by the dot to remove the ASS. So split by dot, then take the 0th element. And then we have the 0, 1. We can then strip it to remove the beginning space or any even trailing spaces. And at the end of the day, we can just cast it to an integer so that it can be an int. Now this is how we can get the episode version, like episode number. And let's put all this logic into one big function so that we can copy paste it easily. So right here, let's create a function called define load subtitles dataset. We give it a dataset path. Then we get we run the glob on it. So we call this subtitles path, and then for path in subtitles path, like that. Then we want to after we do this, we have the subtitles path. We want to read it like this, and then get the lines and then clean them. So let's copy paste the reading. So read lines. And instead of file 0, we can just add the path right here. And then this way we read the lines. Now we can clean them by removing the // n, like this. And then we can put the whole script into one big text by joining it. So join lines. Now this is the script we read in it we read it in successfully. Then we can just get the episode number. We can go here, copy this, paste it right in, make sure to write the path instead of file 0. Then we want to put this into a list and also put the episode number into a list. So scripts like this, and then episode num, which is also a list. So scripts right here, dot append script. Then we have the episode number, dot append episode. And this is the red dataset. The last thing that we are going to do is that we are going to put this into a pandas data frame. Pandas data frame is just a way to display and deal with different types of structured tabular data. So you can read it in by having import pandas as PD. If you don't have it, you can just pip install it. Any version will do here, so we don't need a specific version. And to put those data sets into a tabular data, you can have pd dot data frame, then tell it from dictionary, then create the dictionary that have the column name as the key, so episode. This is the column name. Then what values we want to have it inside, which is the episode number. This is the list of episode numbers that we have. Then we want to have another column that is called script. That is going to have scripts. Let's put it into a variable called df, and let's return this variable right here. So let's try it out. So dataset path equal to backpack subtitles slash star ass. This is going to be the dataset path. We don't need the slash ass. We are going to write it at the top. So yeah, we are not using the dataset path right here. So make sure to use it. So just delete this right there, add this here, and this is the dataset path. So you can just run this, and here write df equal load subtitles dataset, give it the dataset path, and then hope that it won't have any errors. Yeah, so this is the header. Header is just displaying the first 5 rows of this tabular data. So we have episode 1, 2, 3, and then we have the scripts. So at the beginning of each episode, starting from episode 2, it has a similar start, but note that those are like different episodes with different text if you looked into it. Now, before closing this notebook, I want to show you how you can run things on Pandas data frame. So let's run model and just write script like this, which is equal to df.iloc. iloc is a way to get a row number. So you can write iloc of 0. Then tell it to, I want to have the script column, like that. So let's display the script, and you're gonna see that it is a long text. So we can divide the script into multiple sentences so that it can fit into the NLP token maximum. So we can have script sentences, equal to send tokenize, which we imported from NLTK. And this is going to divide the script into sentences. So let's display the first 3 sentences. It is a column like this. And now you can see that it is now divided again back into sentences. So we can put the sentences into batches of 20. So batch sentences, and sentence batch size is equal to 20. So for index in range 0 till length of script sentences like this, and we want to run these sentence batches. So this loop is going to start from 0 till the length of the script sentences, and it's going to increment by 20. So it's going to be 0, 20, 40, so on and so forth. It's not going to be 0, 1, 2, 3, 4. So sent, which is the sentence, is equal to going to be the whole 20 sentences batched together into one big sentence. So it's going to be script sentences of index till index plus sentence batch size, and you can then run it and get the output of it. But let's break this, so we can just run on one and see the sentence output. So this is the 20 sentences batched together into one big sentence. You can remove this, and let's put those new batch sentences into a script batches list that just appends the sentence right here, like this. And let's display the first 2 in the list. So this is the first 20 sentences, and this is the second 20 sentences. Now, in order for us to run it through the model, we can have the theme output equal theme classifier like we did before, give it the script batches, theme list, and multi-labels. But what's new is that we can actually run it on multiple inputs at one time by giving it a list. So let's have this and see the output. It's going to take a while because it's running on 2 samples right now. And here it is. So this is the first classification of the first batch, and this is the classification of the second batch. Now, before proceeding, we can just triangle this dataset so that we can have, for example, battle like this, or like betrayal or anything like that. We can have it like battle, and then a list of scores one by one, so that we can just easily put it into a structured tabular data set, and we can do whatever we want from it there. So let's triangle output. Again, what we want to have it is that we want to have, for example, battle, and we want to have its input as this is the score for the first batch, this is the score for the second batch, and so on and so forth. That is what we want. So let's have for output in theme output like that. Then what we are going to do is that we are going to loop over the labels and the scores together at the same time. So for label score in zip, and this is how we loop over 2 lists at the same time. So output of labels and output of scores. And then if label not in themes, and themes here is going to be a dictionary. This is the output dictionary that we want. So if label is not in themes, then we have the theme.label is equal to a list. Otherwise, and afterwards, we are going to append the score. So let's run this, and let's display the themes right now and see how it goes. So this is dialog, then it has the score for the first batch, then it has the score for the second batch, and so on and so forth. And yeah, this is, we are almost done with this. So before just proceeding, let's put this into one big function, then try and call it into pandas. And yeah, we will be done with this. So define a function called get themes inference, put a script as input, like that. Then let's first batch the script into sentences like we did before. So what we do is that we sentence tokenize, then we batch the sentences together. So let's sentence tokenize it first, like that. Then we batch it. Then we batch the sentences into 20 sentence increments. Then we want to run model. And the way that we run the model is also up here. So you can just copy it. Paste it right here. Note that we will need to remove this 2. So we will need to remove this because it runs it on the only two samples. But I am going to leave it for now because I'm going to run it locally. Then we are going to wrangle the output. And we also have the code for wrangling the output right here. So you can just copy it. Paste it right here, like that. Note that every theme right here has more than one score. So let's just get the mean of the score. We can get the mean by importing a library called NumPy. This is a matrix multiplication library. It is usually installed with pandas, so you don't need to have a separate pip install for it. Then what we want to do is that we want to loop over each theme. So for theme in themes, like this. Then we want to make this into a NumPy array. Then we want to have the mean of it. And have this as themes. So let's run this. It has an error. So the mean here is not dot mean, but actually np dot mean, like that. So yeah, so this is not an array. This is a dictionary. So just write dot items right here. Make sure you are looping over the key and the value. The output is also going to be a dictionary where the key is the same key, but the value is going to be the mean of the array. So like that. Now with run, I can show you the output. So it's going to be dialog and then just one number, which is the mean of the previous themes that we have. So you can just copy this, go back down here, paste it right in, then return themes like that. You can just run it, and now we want to run it into the data frame. So you can just have df equal df.head, and this will take the first two rows only. Now I have a CPU, so I won't have a full run on that because it's going to take a lot of time. But we are going to move this code to Google Colab, and there we can run it on the whole dataset if we want. So you can display the df. You can see that it only has 2 rows right now. And we want to run this function above on the script on every row, on the script column for every row. So for us to do that, we can have the output themes, and we also have a very convenient way to run a function on all the rows for a specific column that is called apply. And we can just give it the function name, which is getThemeInference, and let it run for a while. Then let's also have it right here. And this is the output. So the first row is going to have the dialogue, and then the score for each theme, like this, like a dictionary where the where the key is going to be the theme, and the output is going to be the theme score, the means theme score. And we can also change this into a structured dataset, column dataset. So what we can do is that we can just have the PD data frame, then give it output themes.toList, and then it will be a table like that. So let's call this theme df, like that. And yeah, let's see it. So this is going to be the score for each row that we have in our data frame right here. So the first row is going to be this row, and the second row is going to be this row. And before we do anything, the last thing that we do in this is that we are going to combine those two together. And we can have this by writing df.theme df.columns. So it's saying add those column names here. And what are we going to add? We are going to add the theme df in those column names. And let's display this. Let's display it right now. So you have the episode script, and then you have the themes that we want to classify. So this is the theme classifier overall. And this is how it works. It's pretty simple. It uses the Hugging Face library. And as you can see, it just uses the theme classifier from the Hugging Face. We give it the input, we give it the theme list, and we give it the multi-label is equal to true, and it outputs it. So what we're doing is just we're wrangling the data set so that it's in a format that we can use easily. And yeah, so let's try and make this code a little bit cleaner for us. So let's create a new folder called utils. Inside utils, let's create a new folder that is called data loader. .py. And inside this data loader, we just want to have the function that loaded the data for us, because we're going to use it into the NER and the character network project, so we don't have to write it again. So you can just copy this function that we wrote before, that is called load subtitles. Then you can go back here and you can import the missing inputs, which is glob and basically the pandas. So from glob import glob, then import pandas as PD. And this is the load subtitles dataset has been put into the utils folder. And in order to expose it, we create a file called like underscore init init, then underscore dot py, then say from dot data loader import. What we want to import is this function. So this is how we expose this function outside of the utils folder. So yeah, we can just close it right here, go back to the theme classifier, and then write a new file that is called theme classifier.py. Now the theme classifier.py will have the class that is called class theme classifier. We are going to have an init function that is called when the class is being initialized. It takes in self, and it also takes in the theme list that we want to have. Like this. Let's pass it for now. And it also has the function that is called define load model. And if you remember that, we also have the load model in the IPYNB file. And let's do it step by step. Let's do the init first. So self.model name, and we've specified the model name to be Facebook BART, this one. So just copy it, paste it right here. Then self.device. And we also had a little bit of logic for those here. So it chooses a CPU or a GPU depending on what's available. So we don't need to hard code it. So import torch like that. And then we want to specify the theme list. So theme list is equal to theme list. And then we want to load the model. So self.theme classifier equal to self.load model, and give it the device. And we also wrote this function. So you can go here, just paste it right in, add the self, make sure that it has the correct indentation. Then for the model name, write self.model name. Then for the pipeline right here, we imported it from Transformers. So you can write from Transformers import pipeline. And this is how we load the theme classifier. Now we also have a function that is called get theme inference. So let's copy it also and paste it right here. I'm scrolling through to find it. So yeah, you can just copy it when you find it right here, and then paste it right in. You will need to also adjust the indentation, add the self, and then make sure to add the missing requirements, which is from nltk.tokenize import sentence tokenize. There is also theme classifier, so we can just refer it from the theme classifier self, then add the self.theme list. Go back again, you can find that the model needs, like this function needs numpy, so go back again, import numpy as np, and while we're at it, import pandas as pd, because we're going to need those. So if you remember, this batches the data, runs the model, and then wrangles the output. Now the last thing that we are going to do is that we are going to have a function called get themes that runs this get themes inference in the whole pandas data frame, which is the whole data set. So write self, it takes in a data set path to read the subtitles from, and it also takes something called a safe path that has a none, and I am going to After finishing processing everything, I am going to add to save this processing into a safe path so that I can have some sort of a stop or a checkpoint where I don't need to run this whole model again to find the output. I just can read it from the stop. So let's load the model. So it's df equals, then we want to use the load subtitles that is in the utils. So if you scroll back again up, we want to import it here. So we can import OS like this, then import system, then import path lib. And all this is because I want to go back one file and import something from here. So what we want to do is we want to get the folder path first, that the current folder that we are in. So write path lib dot path, then give it the __ file, give it the parent, and then write resolve. This is the folder path. And let's append this folder path to our system. So system.path.append, then write folder path, and then go back one directory so that we can refer to the utils. And write from utils import load subtitles data set. Like that. And if you go back again here, you can write load subtitles dataset, give it the dataset path, and right now we're going to have the pandas data frame. Now we want to run the inference like this, and like we did before, we are going to use the apply function. So output themes like this is equal to df of script, then dot apply, then give it the self dot get themes inference. Afterwards, we want to wrangle the output to add it into the same pandas data frame. So if you remember here, we also merged it together into one big data frame like this, like here. So that is what we're going to do. So themes df equal pandas data frame output themes dot to list, then df of themes df dot columns is equal to themes df. Then what we want to do at the end is we want to save the output as a stub. So if save path is not none, we can save it as a CSV file, which is a format for tabular data. So df.csv save path and index is equal to false. Now before closing this, we also wanted to install a couple of libraries, NLTK libraries like this, NLTK punct. And in this, actually, you just needed to have it one time. You just needed to install it one time. So we are going to install it here also. So NLTK punct download. And let's also have the punct tab. Now, one thing to add here is that this was casted to an str. It is actually an str, but we instead of having the plus, and this is going to be problematic because if we have slash, if we don't have a slash, it's going to bug because it needs to have the folder path slash, then whatever we want. And if we have a slash and then add a slash here, it's also going to have double slashes, so it's also going to crash. So the best way to do it is have the os.path.join, then give it the path like this, and give it the what you want to join, and it would add it quite easily. So the utils here have a squiggly line, which basically means that it is not detected. It might be just the VS Studio thing, or it might be an error, so we'll figure it out when we run it. And let's now create the GUI that is going to run this. So for the GUI, we are going to use a library called Gradio. So Gradio app.py, and you can have a function that is the main function. Then write print hello world, make sure that everything is working fine. Write if name is equal to main, we can run the main function. So you can run this and you can find the hello world right here. So let me onboard you on Gradio quite quickly. So right here, the Gradio app is a very simple way to create machine learning applications and web GUIs. You can see that it can input images, it can input audio, it can input a lot of stuff, and we are also going to use this for our project. So go back again to the requirements to add the Gradio application. So go here, write Gradio, then write equal 4.36.1. This is the exact version that I'm using. So you can close it again, and you can go back to your Gradio app, and you can start writing the GUI and how it looks. So let's import Gradio first. So import Gradio as gr. Then here write with gr.blocks as iFace, and this initiates gr blocks, and we are going to structure it with rows and columns. So let's first create a row. Let's here tell you what I'm going to do. I am going to create a row with this, and I am going to add the theme classification, which is going to be just an h1 HTML tag. Then I'm going to add a column with this output. Then I'm going to add a column with this input. So let's first add this gr dot row like that. Then I am going to add a gr dot column like this, and go gr.html like that, and write h1, write some normal HTML, which is going to be theme classification 0 short classifiers, and this is going to be the HTML that is at the top right here, like we're seeing. And then we are going to create a new row. So gr.row, and we are going to start by the output plot. So we are just going to write it plot gr. Of bar plot. It's not going to be a plot, bar plot, and then we can remove this. We can also have like this is the this is in a column, so gr.column like that, and this is the output place. Let's also add the input place, and the input has 3 different inputs. So it's going to have the theme, which is also just a string, a subtitles or a script path. That's the folder with the subtitles, which is this one. And the last bit is going to be the save path that we want to save the model in. So save the output in. So let's start by having the theme list is equal to gr.text box. Give it a label that is called label like this, that is called themes. Then let's do the same thing for the subtitles. And let's also add the gr of text box like that. And let's give it also a label that is called subtitles or script path. Now the last bit is going to be the save path. So save path, which is equal to also gr.text, and you can write also save path in the label. Now if you see here, we have also a button. So let's add this button that is called get themes. And you can write this button as get themes button, which is equal to gr.button of get themes. Now this here is runnable. So let's run this and see how it looks. So before running it, we just want to call the interface and launch it basically. So we can have iface.launch where share is equal to true. Now let's save this, clear the output, and then run it. So here's the output URL. You can just copy it, go here, paste it. You can wait for a while for it to load, but you can see here that here's the plot, here's the 3 different outputs that we have, and here's the button. And I think the output should be in its column. So I think there is an error or an issue with the columns and rows. So let me check it and come back to you real quick. So right here, I did a small mistake where I did not indent this into the column of the theme classification. So all you have to do is that you can just tab it right in and close this, clear it, and then run it again. You can go back to your local host and then refresh it, and you can see that the plot here is in the correct place. Now the idea here is that this button does not do anything. We want it to train and actually get us the output and put it into the plot. Now before we continue, we save the output here, and if we want to also have the output to be read, so we read saved output if exists. So if it exists, I can just read it in and not run it again, saving me a little bit of time. So save path is, so if the save path is not none and os.path.exists, so this path actually exists, I am just going to read it in and I am going to return it. So yeah, so that is it. You can come to your terminal, press Ctrl+C to close the current run, clear it, and then go back again to your Gradio app, and then we want to specify what this button does when it is being clicked. So you can go here, get themes dot click, right, get themes like this, where the inputs are going to be the theme list, the subtitles path like this, and the save path like that. And the outputs are going to be the plot. So the outputs is going to be just the plot. Now this function is not defined yet, so let's go and define it. So define get themes, where the input is the theme list, the subtitles list, and then the subtitles path, and then the save path. So the first thing that we are going to do here is we are going to get the theme list Currently it's comma separated, so this is the theme list str. It's a string. We can split it like that with comma, and this is going to be the theme list. Let's also initialize the theme classifier. So theme classifier, and let's initialize the theme classifier. And in order for us to expose it outside of this folder, you can create a new file called init.__.py. Then from, like here, dot theme classifier, import theme classifier. Make sure that we are spelling everything correctly. So you can come here, save it, and then you can go here in the Gradio and make sure you have the correct spelling. And we write from theme classifier, import theme classifier, like that. So after this, let's go back again to the notebook, and let me show you how we are going to visualize it. So we can go here and write visualize output. You can see here that for every theme we have a number like this, numbers like this, and I am adding also something called a dialogue theme, and this is just normal conversation between any two, because not every words are going to be classified into those themes. Some of them are just normal conversations, and I need to put a class where I can classify this so that I can drop this if I want. So in the visualize output, I can just, first of all, I can drop the dialogue. So I can have this, so drop dialogue. Let me copy paste it, where axis is equal to 1. And this removes the dialog column. So you can have it like this. And then we have one number per episode, per theme. And what we want is that we can just get the mean of those for all the episodes together, so that we can understand it, or we can just sum it up. So let's drop the episode and the script. We don't need them here anymore, where axis is equal to 1. Then we want to sum up the other columns altogether. So let's see how it looks. So this is the summation of all the themes together, and if we want to have it again back into the data frame, which is a table, you just write reset index like that, and you can see that it's now a table, but it has some weird columns. So we can just rename the columns together. So just write theme output, and write theme output dot columns, which is equal to theme and score, and then display the theme output, and there we go. This is the output output table that we want. Afterwards, we want to convert this into a visualization. So in order to convert it to a beautiful visualization, we need to import two libraries, which is importing matplotlib.pyplot as PLT, and make sure to pip install it, and also pip install Seaborn as SNS. And Seaborn just makes the plots from matplotlib a little bit neater and visually appealing. So we are going to use this. And yeah, make sure to have the matplotlib spelled correctly. And yeah. So in order for us to, so let's visualize it right now. So SNS dot bar plot, we can give it the data, which is going to be theme output Then there's an extra P right here, so make sure to remove it. Then I have the X, which is equal to X theme. This is the X-axis that is going to be the theme, while the Y-axis is going to be the score. Then we are going to have the plt.show to show the plot. So that's the plot here right now. It shows you that battle is the most, sacrifice is the second most, so on and so forth. And note that they are overlapping a little bit. So in order for us to deal with this overlap, you can just have the plt x ticks, which is those, rotate them by 45 degrees. And this is going to be how it looks right now, a lot neater. And we are going to copy paste this code into the Gradio get themes so that we can have it right here. So here we want to just run the model after we initialized it. So let's have the output df, which is equal to the theme classifier to get themes, and then we want to remove the dialog if we have it. So remove dialog from the theme list, and then we can have it like that. Let's have a theme list like this, where we loop over each theme list, and if the theme is equal to dialog, we do not take it, but we take everything else. And then we have the output df takes in all the theme list right now, and we assign it again to the output df. So that is how we choose the theme columns. Now, like we did in the IPYNB, we want to sum it or get the mean or whatever. So let's do that. So let's have it like here. So output df is equal to going to be the output df of theme list, which is like that one. Then we write dot sum, and then we reset the index. And after resetting the index, we knew that we had a couple of weird columns, so we can write it as this. And at the end of the day, we want to visualize it, but we will not be using matplotlib or seaborn. We will be using Gradio. So output chart is equal to the gr dot bar plot. Gr is Gradio. And then you give it the output df. Then you give it the x, which is going to be the theme. Then you give it the y, which is going to be the score. Then you give it the title, which is going to be series themes. Then you give it that tool tip, which is going to be the theme and the score. And then we wanted to have it vertical like this. If we wanted to have it vertical like this and not horizontal, then we specify that vertical is equal to false. So we wanted to have it, this is horizontal, so we wanted to have it vertical. So we specify vertical is equal to false. And we can specify width, which is going to be 500 pixels, and a height, which is going to be just 260 pixels. And let's return back the chart like this. And we can run it locally first. So when we run it locally, we just wanted to run it on 2 or 3 samples because I don't have a GPU. So you can have this df equal df.head2, and this just runs on the first 2 rows. And if you remember, we have the script batches, we run on only 2 of them. So make sure after this run we remove it, and we remove this head equal to. So we can go here and just run it. So you have the link right now, so you can copy it, paste it right here. Then you have the themes that you want to choose. And the themes that you want to choose is here, so you can just copy paste them. You can also enter a subtitle script path. So the subtitles script path is going to be this one. So we can copy path and just paste it right in. And we also want to have an output path. So let's also mention that the output path is going to be stubs. And this is going to be the path of the output. So let's also paste it right in. And we can call it here theme classifier output.csv. And let's run it. We're going to make sure that it ran first, and then we can save it and then go and run it on Colab. So we got an error, and looking at the error, I think that we made a small mistake in the theme classifier. We did not return the df at the end, so make sure to return it. So return df. Here you can find that the theme here is uppercase and this is lowercase. So make sure to have the theme and the score both in uppercase. So you can close it right here, clear it, run it, and we can then open this up again and run the model. And there you go. This is the distribution of the series, but don't forget we only ran it on the first two. So we can go back again to the themes right here, remove this head, and we also remove this 2 right here, which is the first 2 elements of the list, and then we can save it. Now, in order for us to run it on Colab, we will need to put it on GitHub so that we can easily push the code there and we can pull it there. So you can just close it using Control-C, clear it, and then go to your GitHub right here, and you can create a new repository. So press on the plus, press on create new repository. So first we're going to write our repository name. I'm going to write it analyze series with NLP. And I am going to also add a description. And this can be an optional description. I'm going to write this repo builds an NLP system that analyzes TV series with NLP and even create a character chatbot. And you're going to find a little bit of the description right here. Then leave everything as is and press create repository. Make sure to choose an owner. So I chose mine and then write creating repository. So it gives you the commands to actually make the repo. So let's do it right here. And let's first create a .getignore file to ignore a couple of files that we don't want into our GitHub. So the first one is the PYC, which is PyCache. We don't want any cache in our GitHub. Then I don't want to have any cache regarding also Python notebooks, so checkpoints. And I don't want to have the environment variables that I'm going to put in because they are going to be secret and I don't want them to be exposed anywhere. And afterwards, I don't want to have also PyCache. And this is just removing the whole caching in the, from the GitHub. You can then close it, and then you can go here, follow the first command, which is git init. This creates a Git repository. Then we want to add whatever we want, which is all of the things that we want here. So let's git add crawler. So it now added the crawler. We can git add also the theme classifier. We can git add the utils. We can git add the .getignore file. Let's git add it. Sorry about that. We can also git add the requirements. We can git add, actually we can add multiple stuff if we want, like example HTML. We can also add the Gradio app.py by adding just a space. And yeah, make sure to write git add like this, clear it, then write git status to see which files are left and which files are on staging. You're going to find that the data and the stubs are on the are only the two things that are not pushed. So let's have a new file right here, stubs folder.txt. We can remove it later, but I am going to add it right now. So git stubs, and it's going to be stubs folder.txt. And we can commit this by adding git commit -m, and we can write initial commit. Then you can go back here into the GitHub, and you can see that after our first commit, we need to create a branch like this one. So create a branch, then add it to the remote GitHub repository like this one. And afterwards, you can just push it. So this is going to be it. And if you went back again to your remote repository here and refreshed it, you're going to find that your code is now in the GitHub link. Now, let's go to Google Colab. And in Google Colab, right here, let's go to your drive first, right here. And then go to Colab Notebooks. If you don't have this folder, just create it. And let's create a new Google Colab folder, Google Colab file. Let's call it Analyze Your Favorite Series Development. And the first thing that we are going to do is we are going to clone the repo. So, right, clone repo, and go back again to your repository. Just press on this code button, copy the link, and then go back again to your file. Just git clone and then paste it. And to run any terminal command, you need to put an exclamation mark in front of it. Then you can run it. Then we need to install the requirements. So you can here write install you can install the requirements, and you can install the requirements by like changing directories into the analyze series NLP. After cloning it, you can find it by just refreshing it right there, and you can find analyze series with NLP. Then you can just write pip install -r the requirements. Let's run it. So it did not find the requirements.txt, and because it is the requirement, it's only one. I think that is a spelling mistake. So you can go back here, change it to requirements, then git add requirements.txt. Then you can commit it, edit, and make sure to have the get status first. And this is it. So you can commit it, edit requirements folder. You can git push it, and now the code is pushed. So you can go here again, and the beauty of GitHub is that you can just pull the results. So you can have git pull, and that is it. So now the file is updated, its requirements. And you can see that we have also the requirement right here. So if you have the get status right here, you can see that the delete is not staged. So in order to do this, you can write git rm requirement.txt, git commit -m remove old requirement, then git push And let's also here git pull. So you can see that it deleted one file. You can refresh it, and you can see that the requirement has been removed. And you can install the requirements by having the like the command that we wrote in before. So run it right now, but before running it, make sure that you have the correct runtime on. So you can have the change runtime. Make sure that it is a T4 GPU. Run it right there, then save it. It's going to switch machines, so we need to clone it again. So clone it, remove this selected cell, which is the pull, then run the requirements.txt. It will take a while for it to download. So while it's doing that, we can just write the code for the run app, which is run app. And what we are going to do is we are going to cd analyze series with Python, with NLP, then write Python Gradio app.py, and this is going to be download the this is going to run the Gradio application. So you can open it right here, and you can see it right there. So what's left now is that we want to upload our dataset. So you can just create a new folder called data. Inside of this data, create a new folder called subtitles. Then inside of this, you can just press upload, then go to your subtitles, press Control A, then press open, and say OK to this because it says that after the session is completed or closes, this dataset is going to be removed, which we have no problems with. So we're going to wait a little bit for the dataset to be uploaded. It's just going to take a minute or two. And at the same time, we are just going to run the Gradio application. So let's run it. So you're going to find that we have the public URL, and we are going to use this one while on Collab and not the localhost one. So you can go here, and you can find that the application is running. So for the themes, we are going to use the same themes that we used before, like this one. For the data, we are going to use this path. So copy path, just paste it right here. And for the stubs, we are going to use this path. So you can copy the path here and write theme classifier output.csv. And then you press on get themes. So you're going to find that it's running right now. So just make sure that everything is working. And yeah, just leave it till it finishes. It's going to take a little bit of time because it's classifying all the subtitles that we have. We have more than 220 episodes. So it's going to classify all that. So I'm going to cut the video and return back when it's finished. So this is the result after it finishes. And you're going to see that it has the whole themes that we listed, and it removed the dialogue correctly. And yeah, this is it. So you can go back here, you can refresh the folders, and you can open up the stubs, and you're going to find the theme output classifier, and you can download it. Wait a little bit for it to finish. It downloaded. So you can just close down the GPU. So you can just write manage sessions, close the GPU because you have a limited amount of hours per day, and we're going to need them into the other modules as well. So you can terminate it, close it, and then go back to your folder right here, go to the stubs folder, then remove the old classifier that we have, like this one, Then go to your downloads folder, cut this one, and paste it into the stubs folder. And yeah, go back to your code right here, and you can clear the output, and then we can run it again. So you can go to Gradio and run it, and hopefully this time when we run it, it's going to read from the stub and not take a long time running, especially because we don't have a GPU. So just go here, run it on localhost, list down the themes that you want. So let's list them down from this one, like that. Then we don't need to provide the subtitles or a script path anymore, but we need to provide the stubs path. So let's here copy path, and then open this up right here, and press on get themes. And you can find that it read them correctly and it displayed them also correctly. So that's good news. We are now done with the get themes module and are ready to move on to the character network module. So for the character network, we are going to use the same subtitles dataset. So let me show you what I mean. So the subtitles dataset is going to be just this text that we saw before, and then we are going to use to split it into sentences first, and then for each sentence we are going to use a named entity recognition model to extract the names for each sentence. So like this. So for each sentence, this is going to extract the names. So the names are in Japanese, so it might be confusing, but those are actually names. So Kakashi Sensei is a name, Naruto is a name, so on and so forth. And if there's no name in the sentence, it's just an empty list. So this is the output that we want to have, a list of lists where the list is sentences, and the lists inside of it is going to be the NERs inside of the sentence. Then we are going to count the number of times that two characters appeared next to each other within like 10 sentences. So Kakashi Sensei and Naruto appeared 1 time, Kakashi Sensei and Sasuke appeared 2 times. So we can count how many times each 2 characters appeared within 10 sentences. And from that, we can then convert this to a character network like this using Pyviz and Network X. And this is going to be easy for us. So this is the plan for our character network. And I am also going to show it to you in Python notebooks, and then switch from the Python notebook to a file so that we can make it more organized. So before starting, we can just close down all those folders up right here, all those files and folders, and we can close those up here. And then we can create a new folder that is called character network, and make sure you write it correctly, character network. Then create a new file that is called character network generator .ipynb. So it's going to be a Python notebook. Choose the Python environment, and then let's start with named entity recognitions. So named entity recognition is just a normal classification model, but instead of classifying a whole sentence, it classifies word by word. So each word, it will classify whether this is a named entity and which named entity it is. So for that, we are going to use a library called Spacy. So you can go here, pip install Spacy like that, and you can press on this, and you're gonna find the pip install command. So just copy paste this pip install command and just paste it here and run it, and it should be working fine. So afterwards, you just run import Spacy to import it. Then we also want to have the sentence tokenizer from NLTK. So from NLTK, import sentence, import from NLTK, import sent tokenize, like that. And afterwards, let's go to the Spacy's NER models. So one of the models that we are going to choose is Spacy EN Core Web and TRF model. So this is the Spacy's EN Core Web TRF model that is going to get our NERs. And let's also have it in the Spacy. So the first link here is Spacy. So this is also a Hugging Face model that is pushed on Hugging Face, but Spacy makes it really easy for us to use. So you can just click on EN Core Web TRF, and you can see here that here's the download command. So you can go back here and just run this command here. It's going to be faster on my side because I already have it. And yeah, so let's load the model. So load model. We can define the model like this, load model. And we can call it like that. So NLP Spacy, then load, then give it the name of the model. And this is how we load it. So NLP model is equal to load model, and this is how we load it. Quite simple. Now let's also load the data by the same way that we loaded it before. So load dataset. And let's import OS, let's import system, and let's import pathlib. We are going to utilize the function that we have in the utils. So folder path is equal to path lib dot path, then parent, then dot resolve, like that. Then we are going to sys dot path dot append, then give it the os dot path dot join, give it the folder path, and then go back one folder. Then say from utils import load subtitles dataset. So let's load the dataset together. So let's have a dataset path, which is equal to backpack data, then subtitles, like this. And let's have the df equal load dataset path, and let's wait. So this is going to be the dataset loaded. Again, this is what we saw before, so nothing new here. And let's have one script. So let's have just one script. So sample script is equal to df of iloc. Iloc is going to be the choosing of the row of script. And let's display it, and this is the script, just like we saw earlier. Then let's convert it into sentences. So sentences, which is equal to going to be sent tokenized, and give it the sample script, like that. And see the sentences. It's going to be a lot of sentences like that. And let's choose only the sentences between 60 to 90. So 60 to 90. Now I chose this because it has multiple NER It has multiple NER types, so I wanted to show you those multiple NER types. And I want to show you also how we can run this NLP model, like NER model, on the sentences. So write sentence equal dot join. So we are going to join it by a dot, so dot join, and give it sentences. And make sure to assign the sentences right here. And let's see the results. So this is the sentences that is divided by dots. And yeah. Now let's run the model. So run model. Let's have it as document equal NLP model of sentence. Just give it the sentence that we had above. And to see the results, just write doc ents. And you see that those are the named entities that we have: Ninja, Fourth, 9, Leaf, Ninja Academy, Tomorrow, Naruto, and One. We have a lot of entities here, but as you can see, Ninja Academy is not a name for a person. Tomorrow is not a name of a person, but tomorrow is time, and Ninja Academy is a place. So in order to see this, we want to see the label of each one. So for entity in doc ents, I am going to print out the entity, and then I print out the label. So this is it. So for the Ninja Academy is an organization. As you can see here, we also have tomorrow is a date, and we also see that 9 is cardinal, which is just a number. And then we have the Naruto, which is a place, which is a person. And as you can see here, we just want to specify and take only the named entities that are persons and ignore everything else. So let's create a function for that where we can get those NERs. So define get NERs inference, then give it the script like that. Then write script sentences, which is sentence tokenize. Then we are going to have the NER output as an empty list, and we are going to append on it. Then we loop over each sentence, and then we want to run the NER model on it. So each document, we are going to run each sentence through the NLP model, get the document, and then we will loop over each entity in the entities. Then if entity dot label equal person, then we have the full name, which is equal to the entity.text, and the first name is equal to the first word of the full name. So if it had multiple words, we only choose the first one. And then we can strip out any leading or trailing spaces, like this. And for this sentence, we want to put it into a list of NERs. So NERs is equal to I'll set, because I don't want any duplicates in one sentence. So let's have this add first name. And after this, we want to add the NERs to the NER. So this is going to be the sentence output. And we are going to put all the sentences together into this one giant list. And then we return it. So this is how we do it. So again, if you remember this, this is going to be the output of this, basically. This is the output of the step. So let's run it. And let's get the df equal df.head of 10. Let's just have the first 10 rows. Let's display them. And let's run the NER on those 10 rows. So df of NER, which is NER column. We are going to create a new column called NERs. And we are going to have the script.apply, then run it on the get_NERs inference. And we are going to wait a little bit because it's going to run it on the whole 10 rows. And I'll come back to you later. So now it's done. We can continue with this. So we can see the results here. And you can see that this sentence has Naruto, and then it has others as well, but we can see the full result set. And yeah, this is it. Now let's convert this to the thing that we want here, to this data frame that we want. And then we can convert this data frame again back to the character network. So let's create a new section called character network. Let's import pandas as PD. And we also want to import matplotlib.pyplot as PLT. And then we want to have two libraries, that is network X and Pyviz. So you can go back again to your requirements here and write Pyviz, which is equal 0.3.2. And this is the Pyviz library. Make sure to pip install it. And it will install the network X with it. And if it didn't, just pip install it using the normal Google, like the command that you find in Google. So you can come here, right, from network X, import as NX. So, sorry, it's import network X as NX. Then from pyviz.network, import network. Then run this. So we are going to create a function called generate character network that is going to take in this input that we have right now and convert it to this input, and then it's going to be easy for us to convert it to a network. So for this function, let's call it define generate character network and put df in as the input. Then specify that the window size is going to be 10. So if 2 characters appeared within 10 sentences, then we increment the counter. And then the output list is going to be called entity relationship, like this. And it's going to be a list, an empty list. So for each row, which is going to be for each episode, in df of NERs, for each episode, we are going to be looping over each sentence. So for each sentence in the row, then we are going to start our logic. So we need to keep track of all the previous NERs that happened before. So let's define a previous entities in window, and let's define it as an empty list. And for here, we are going to have the previous entities in window append the list of sentences. So basically, this appends all the entities that is currently in the sentence, and it puts them into a list. And right now, this is going to be a list of lists, so it's going to be like this. So it's going to be list, and the first sentence is going to have Naruto. Then the second sentence is going to have Sasuke. Then Sakura. Then whatever. And it's going to have, like, it's going to be a list of lists where each one is going to be a sentence. So it's going to be a 2D list. And this is it. So we are adding right now the first one. And after this, we just want to have the last 10 of those. So let's have the last 10 sentences like this. And let's not do it in hard-coded fashion. Let's have minus window, which is the last 10 sentences like this. And then we want to flatten this 2D list into a 1D list. So let's have this. So flatten 2D list into 1D list. And to flatten this, you can run the previous entities in window, like previous entities, let's call it flattened. And this was suggested wrong. So in order for us to make it 1D, you just write some previous entities in window and then give it an empty list like this. And this will flatten it to be like that. So it's going to be Naruto, Sasuke, and Sakura, like this. So this is the 2D list that this is the 1D list that we are going to have. Then we can loop over each entity that we have in the sentence. So for each entity in the sentence, and we can also loop over each of the entities that is in the window, which is the flattened one. Entity in window in previous entities flattened. So we can say that if the entity is not equal to the entity in window, it's not the same character, then we can append entity relationship, which is this one. We can append the entity and entity window. But before we append, we need to sort them first. And why we sort them? Because if the first entity is Naruto, and the second one is Sasuke, and we append this, it's going to be Naruto and Sasuke. But if we have the same Naruto and Sasuke, but the order is misplaced, it's going to also have the output going to be like this. So Sasuke, then Naruto. And this is not going to be a bidirectional, it's going to be a one-directional character network. So this variation is going to only confuse us. So what we need to do is that we need to take those and we need to sort them out so that Naruto and Sasuke can be Naruto and Sasuke based on the alphabets. But Sasuke and Naruto can be also Naruto and Sasuke if we sorted them. So this is the reason of sorting. It's making things more standardized. And make sure that it is a list before we continue. And yeah, we are almost done with this. So right now we have the entities listed as much times as they are repeated. Now we just want to count them out. So we can count them out easily using pandas. So let's have this. So relationship df is equal to pd.dataframe, and then give it the value column. And in the value column, give it the entity relationship. And we want to also separate this between a source column, like a source character, and a target character. So let's have this as source, which is equal to relationship of value. Then we need to apply lambda, then get the 0th element. And this gets the element number 0, which is this one, which is going to be sorted. So it's going to be the first element and it's going to be the source. And for the target, like this, let's also have it value, and let's take the element number 1. And to count how many times they occurred, we can have a group by statement with count. So relationship df dot group by. and we can group by source and target together. Then we can have the count how many times they appeared, and then we can reset the index so that we don't have any weird indices. And let's remove the name part here. And for the last bit, we just want to sort them out. So let's sort values based on the value column, because it's going to count them and put them into the value column again. So where ascending is false, so that we have the descending in place. So this sorting is going to be descending, so that the most characters that appeared are on the top and less significant characters are at the bottom. So yeah, so this is the relationship df function, and now we can just call it. So let's call relationship df get character network and give it the df. So I got an error right here, and right here it made it extend, and it should be append because it's a list. So you can have it right there. And yeah, let's check it out. So you can see that Naruto and Sasuke appeared 117 times, Sakura and Sasuke appeared 65 times, so on and so forth. And this is similar to what we have right here. So this is very close to the character network that we have at the end. And all what's left for us right now is that we are going to write the code that creates this character network, takes in this data, and creates in this character network. So let's take this again right here, and let's sort the values out again like this, with ascending is equal to false. So we had already this, but I'm just rewriting it to make sure that we have it. Then let's take only the first 200 characters, because otherwise things are going to be very messy, and it's showing a lot of characters in the network, and we are not going to be able to visualize it quite well. So limiting it to the most important characters is going to help us have a cleaner neural network to see. Then we can transform this into a network by using the network X library. And you can have this by having nx dot from pandas edge list, like this. We want to give it the relationship df, like that. We want to provide the source, which is the source column. We want to provide the target column, and we want to provide the attribute column. And then we want to provide an engine, create using nxggraph. And so we want to change this into a Pyviz network because it's more visually appealing to see those. And network X visualizations are messy, especially if you have 200 characters to see. And it's not even interactive. So let's change that to network, which is the network that we imported from Pyviz. We can specify that the notebook is going to be equal to true. Width is going to be equal 100 pixels. 1000 pixels, sorry about that. Height is going to be equal 700 pixels. Then I am going to also specify a background color of a blackish color. Then I'm going to specify a font color of white. Then I am going to specify the CDN resources equal remote. Then we can specify that the node degree, which is the node how big the node is going to be from g.degree. And we can specify that this degree is going to impact the size. So nx.set node attribute g and give it the node degree, and then make it affect the size. Then net.from network x and give it the g. then net dot show, then Naruto dot HTML. So this is going to show the network. If you're using the Python notebooks, normally it will show up, but if you're using the VS notebook, like the one that I'm using, it might not show up right here. So you can just refresh it and you can find the Naruto.html has been generated. So we can go ahead and open it. Just wait a little bit for it to load, and this is how it looks. So you can see that it's interactive. The main character, which is Naruto, is the biggest node. The second, which is Sasuke, is right here. We have also Sakura, and how thick the line between those is how close those two characters are from each other and how often they occur with each other. And yeah, this is it. So you can just save this Python notebook, and we can go ahead and write it again into Python files. So the first thing that we are going to do, we are going to write the NER named entity recognizer. So we are going to split this into two files, one for named entity and one for character networks. And let's have the class named entity recognizer, and let's remove all this and write just path. Let's give it the self, and in the self just load the model, so NLP model, which is equal to self.load model, like that. And we can go ahead in the Python notebook again, and we have this function, so just copy it, paste it right here, make sure to add a self like this, and make sure to also import Spacy. Then we have the get NERs, which is going to be this function. So this is the get NERs function, and let's also make it take self, and make sure to add self into the NLP model, like that. And right now the sentence tokenizer is not imported, so from nltk.tokenize import sentence tokenizer. And at the end, let's create a function called define get NERs that has the self, that has the data set path, that has the save path, which is equal to none. And like we did before, we're going to have a stub that is going to help us read the output if we run it before. So let's load the dataset first. And to load the dataset, we are going to use the same things that we did right here. So just copy this and paste it right here. And let's use it here. So let's have df equal load dataset and give it the dataset path. Then we can run the inference. So df of NERs is equal to the df of script.apply then self.get NERs, get inference. Then if the save path is not none, then we can just save it as a CSV, save path and index. And if we have this, if the save path is not none and the OS path exists, by the way, it has an underscore in between them, like this. So what we do is we want to read it. So df.pd.read CSV save path. make sure to import the pandas library. Import pandas as PD. And since we are reading a CSV, CSVs do not handle lists as column values as well, because right now we have a list as a column value. Let me show you to you again and remind you about it. So this is a list as a column value. So it's going to save it as a string, and we need to shift it back from a string to a list. And this is how we are going to do it. So we are going to have it as NERs. And then we are going to have a lambda function. By the way, a lambda function is just a one-line function where x is the input and x is the row value of this of the NERs, and it's going to loop over it row by row. And we are going to use also a library called from AST import. This does not need to be installed. It is in the default packages. So you can go from AST import literal eval, and you can come here literal eval and give it x. And if the is instance of x is an str, then we are going to make it again into a list and then return back the df. So this is our named entity. This is our named entity file, and it is quite simple. And we are going to have a similar file for the character network generator. So let's do this. And make sure to spell it correctly. So there is an A right there. So yeah, just write class character network like this, generator, define an init. And in the init, we are not going to do anything. So let's just pass it for now. And let's generate the character network. So we have this function also ready for us. So generate the character network, just copy it. Go back again here, just paste it. And go here and import pandas as PD. Make sure that nothing has squiggly lines and nothing is broken. So everything looks good right now. Then let's have a function called define draw character network. So define draw network graph, and take in the self, take in the relationship df, and you can just remove this. So write relationship do df, and let's sort the values based on the number of occurrences. So we can do that easily by doing this. So just copy, go back again to your character network and paste it. So sort and take the first 200 values. Then we want to make it into a network like the one that we did before, like this. And we want to import the network X and Pyviz. So you can go up a little bit till we have the imports, which is the network X and Pyviz, those two. Go back here, import them. And the last thing, that we do not need to save it into an HTML file right now. So we can just get the HTML of it. So we can have it like this, HTML equal to net dot generate HTML. And let's clean the HTML a little bit, so that HTML dot replace. So it has single columns, single commas. So every single comma that it has, we want to make it into a double quotations to not break the code. And then we are going to define an output HTML that is going to be an iframe that is going to have our hosted HTML right there. So let me go and get this iframe and paste it right in. So right here, so we can paste it. You can just copy paste this, and this is an iframe that is going to display HTML inside of it. And you can see that it just has a couple of attributes, and then it pastes in the HTML as its source code, the HTML for the network as its source code, and then we can just return it back, output HTML. Now in here we want to expose both outside of this folder, so we want to have init and init.py like this. Then you can go here .from named entity recognizer, import named entity recognizer, and from character network, import character network, and this is how we can expose them outside. Now we are ready to have it into the Gradio app and run it. So you can go back here, then you can copy paste this section right here. So copy it, then right here, paste it right in, and have a small comment that says this is the character network section. So in the character network section, let's call this character network with NERs and graphs. And the output here is not going to be a plot anymore, it's going to be some HTML. So let's have it as network HTML as gr.html. Like this. And we can also have a small comment up here that is called theme classification section. Then let's have it as let's have the inputs. So let me remind you of the inputs that we have. It's going to be a subtitles path and the NARs path, and that is it if we have any. So subtitles path is equal to gr.textbox, and give it the subtitles or script path like this. And for this we can for this one we can delete it, and this one we need to put it as NER path, and the label is going to be NER's save path. Let's get the network, so get network graph button like that, and let's have the gr.button, and this is the get character network button, so get character network. And we want to also specify what it does when it gets called. So we want to have the get character network function get called that we didn't write yet, and we want to have the inputs as the subtitles path and then the NER path. And for the outputs, I wanted to have the network HTML path. Now this is it. So let's just comment out the click so that we can run it and just see the how it looks, and there is no error in Gradio. And then we can write this function and see the functionality of it. So clear the output, go here, run it, and wait a little bit for it to finish. Copy the URL, go here, paste it. So this is the theme classification bit, and this is going to be the character network bit, so everything is working fine. Let's go ahead and write the get character network function. So here, let's define get character network function that takes in the subtitles and the NER path. And for the NERs, let's have the named entity recognizer, and let's import them. So from character network, import named entity recognizer, and we want to also import the character network. Then let's run the NER model that's run the NER class. So NER_df is equal to NER.getNERs. This is the function that we wrote. Then give it the subtitles and the NER path. Afterwards, we want to have the character network. Character network generator, so like that. And we want to have the character network generator like this. Then let's get the relationship df. So you just write the character network dot generate character network the character network function, and let's go back and make sure that we have the correct spelling for it. So it doesn't have the self, so make sure to add it. And yeah, everything is good. So just copy it, go back again to Gradio, and paste it right in. And this is the NER path. And after we get it, we want to just draw it. So character network.draw graph and give it the relationship df. Then return back the HTML. Now the idea is also that we are on a CPU machine, and it's going to take forever to run it on all of that. So let's limit this to df equal df.head of 10, and we can remove it later. And let's make sure that we are not limiting anything else. I don't think that we are. And yeah, so this is the only line that we will remove. So let's stop this. Control C, clear, and save this, and make sure that in Gradio you also save it, and make sure that you have the button. This button is not commented out. And also you can see that this get character network graph is not used because I made here the get themes button. So just press this and make sure to remove the get themes button, save it, and then run. So I made a small mistake in this in renaming this. So you can go back here and you can just write it correctly, which is character network, like this, generator. Then you can copy it, paste it right here, make sure that the init has the same file name as the original file name. Just close it, clear the output, then run it again. So it still has an issue. Just make sure to rename it, like copy it, make sure to paste it right here. You're gonna find that it's now colored with green, so I think we're good right now. And run it again. So go back to Gradio and run it. So go to the link that is provided. So you have the subscript path and the NER path. So let's give them both. So the script path is going to be this one, which is the subtitles path. So copy path of that. Go back here. Where is it? So yeah, you can go back here. And the output path is going to be in the stubs. So go to the stubs folder, copy the path, go here, paste in the stubs, and write NER output.csv. And you can just click on generate network. So I received an error here, and again I did the small mistake of not returning back the output that I was processing in the NER's entity recognizer. So make sure to return it and go back here, make sure that you are returning back the outputs. So you can close this, Control C, clear, and run it again. You can go back here and you can run it again by clicking the button. And now we have it done. So look at this again. So we have Naruto, we have Sakura, we have Sasuke. It's interactive. We can zoom, and because we only run on a couple of on 10 rows only, you can see a couple of side characters right there. It should be removed when we run it on the full data set because the first 200 characters would be very important. So yeah, and yeah, so now we can just commit it, put it to GitHub, and then we can run it on Colab to have a full run on that. Before that, I have found, like, it's not a mistake, but something that annoyed me is that I put the entity.txt in full name. I did not use full name here. So just write full name right there. Just annoying that I put it and did not use this variable. So you can close it, Control C, clear, then write get status, like that. You can see that the requirements has been edited. So you can just get diff. You can see the difference of it. So you can find that Pyviz has been added and there's a new line in the Gradio. So you can just add it right there. You can write get status again to see what's changed. So the Gradio app, of course, because we added another element. So make sure to add it. And before we do anything, we have the head here. We want to remove it. So make sure to remove it. Go back again to your Gradio app. Make sure that we have no limitations on the run. So there is no limitations right here. So you can save it. And right now we just want to add the character network. So add the character network and write get status. So everything here seems to be added correctly. So you can just git commit -m and then call it add character network, like that. Then git push. So let's go to our Google Colab again and clone it and make sure that you're not a robot. That's fine. And then you have the pull. We don't need it right now. Then you can install the requirements. And then we have another requirement. So in the Spacy, and don't forget to download it. So just copy it right here and go to the cell that is underneath the requirements and just paste it right in. And then we can run the Gradio app. And while it's downloading the requirements, make sure to create a new folder. Call it data, then create inside of it a new folder called subtitles. Then upload your subtitles. Just upload, code live, like this. Go to your data, subtitles, then choose all of them and press upload. And it will be uploading it. So we can wait a little bit for it to finish. Awesome, so now it's done. We got the URL right here, and we also uploaded the subtitles. So you can go to the URL, paste it right in, and we can get the subtitles path like this. So you can copy the path, paste it right in here, and you can go to the NLP stubs. You can just copy the path of the stubs like here and write ner output.csv, and you can just press on the get character network. So this is going to take a while for it to run on the 220 episodes. So I'm just going to cut the video and come back when it's done and make sure that it's not crashing or anything. So now it's done. It ran on the whole data set, and you can see here that this is a better character network. You can see that Naruto is the main character. You can see also Sasuke is a big character in this, and you can see the interaction between them is a lot. And yeah, you can see other characters as well. And if you know the anime, you can go into the nitty-gritty detail of each and every character, and it is quite interesting for you to play around with. And yeah, congratulations on that. So for us to continue on that, you just can go to the stubs, make sure to refresh the folders first, go to the stubs, then download this NER output, which is the stubs for the NER. It's going to take a while because it's a heavy file. And it now downloaded right here. So go to the go to the manage sessions, like here, and make sure to close the GPU because we have other modules to run. So close it, then go here and go to the stubs and delete the NER output that we had before, and go to your downloads, get the NER output, then paste it right here. So this is it, and we can also run it locally. So you can go to the Gradio app and then you can just run it right here. It's going to run from the NER stub and not run it, so that's why I am testing it. So you can go right here and you can just get the path for the NER output, which is copy path, then go here, paste it. You don't have to get the subtitles anymore, so you just run it, and there we go. It's also working. It takes a little bit to load, so yeah, there we go. So Naruto, Sasuke, and everyone is here. So that is it. In this section, you learned a lot about what NERs are. You learned how to wrangle stuff. You learned to also how to put it into a beautiful character network and how you can make connections with it. So yeah, so moving on to the next section, it's going to be for the text classification section. So basically, it's based on the the dataset that we crawled. We are going to paste in the name and the description of a jutsu, which is a fighting technique. And we are going to put either ninjutsu, genjutsu, or taijutsu. And we are also going to save this model into our own Hugging Face hub so that we can download it easily in other places and other servers, like for example Gradio, or like the collab that we're using here. So yeah, a lot of good stuff right here. So let's get to it. So let's create a new, let's first close down all this and start on a fresh plate. And let's close down this. Let's create a new folder called text classification, like that. And let's create a new file in it that is called jutsu classifier development.ipynb. Jutsu classifier development.ipynb, and this is going to be a notebook to just also show you what we're going to do and how are we going to wrangle the data and how we're going to use the model for that. So yeah, let's do this. So let's have the first thing, which is load dataset right here. And let's have a data path of back data, and it's going to be the jutsus.jsonl. So it's going to be this path. And we are going to read it with pandas also. So df pd.read JSON and give it the dataset path. Tell it that this is going to be lines equal true and have the df.head. And before running it, make sure to import it. So import pandas as pd. Make sure to choose an environment. And this is the dataset. So it's going to be a table with the jutsu name and the jutsu type that we have and the jutsu description. The first thing that we notice is that we only want to have ninjutsu and genjutsu and taijutsu. We don't want to have all of this Keki, Genkai, Ninjutsu, Taijutsu. We only want to have like either Ninjutsu, either Taijutsu, or either Genjutsu. So let's do a function for that. So we'll create a function that is going to simplify those jutsus. So define simplify jutsus, and it's going to take a jutsu, and if there is genjutsu like this, if there is genjutsu in the jutsu, then we are going to return genjutsu. Then if we have the ninjutsu like that inside jutsu, we are going to return ninjutsu. And if we are having taijutsu, make sure to spell it correctly, return taijutsu. So this is the function that we want to run on all the rows for the jutsu type. And we can do that with the normal pandas function that we have, the normal apply function. So df of jutsu type simplified is equal to the jutsu type dot apply and give it a simplified jutsu. We can just run it, have the df.head on it like this. And now we have the simplified jutsu, which is ninjutsu, ninjutsu, and taijutsu. So that's an easy way to simplify the jutsus and make it into different buckets. And let's now see how much we have from each type. So let's have the jutsu simplified.value counts. It's values counts, value counts. I wrote it wrongly. So we have 2,225, 2,255 for ninjutsu, 300 something for taijutsu, and 100 something for genjutsu. And this is what we call a skewed data set, where one class has significantly more samples than the other. And this is going to add complications for our training set. But at the end of the day, we are going to handle it. And it's going to be in your toolbelt that you trained a model that has a skewed data set. And if your model is not skewed, then you can just have a better and have a simplified way of training it. So let's continue with this wrangling of the data set. Let's put the name and the description in one column called text. So let's just have the jutsu name plus space, and you can just add a dot right here, and you can add jutsu description afterwards. Then you can just write the jutsu, which is going to be equal to the jutsu simplified column, which is this one. And then let's only take the jutsu's text and jutsu's column, like that. And let's drop any NAs. So any missing values, let's drop those rows. And yeah, so let's get the head of it. And this is the text and the class of it. Now, because we are running it, because we scrape this data from the internet, sometimes it has like HTML tags that slipped in and things like that. In our case, it doesn't, but some cases it does have some HTML tags. So we should create a function called cleaner. And in this cleaner, it is a good practice to have it. It's not necessary to have it here, but I want to also show you the good practice. So you can have the init self. This is responsible to clean the text, and we can have this. So let's have a function called clean that has the self and the text. And the first thing that we are going to do is that we want to basically put a line break after each paragraph, because paragraphs means that after it there is a line break. So let's have this. So define put line breaks. So when we remove the paragraph tag, then we can easily have the same indentations in. So what we want to do is we want to replace a closing paragraph tag like this. We want to have it like that, so a closing paragraph tag, but after it we are wanting to have a new line. So this is it. And let's also remove HTML tags. So let's remove HTML tags. And when removing HTML tags, we are going to use Beautiful Soup. So from BS4, import Beautiful Soup. And let's have the clean text is equal to the Beautiful Soup. Give it the text and have the parser as LXML. And let's only get the text of it. And let's return back the clean text. So in the clean function, which is the main function, we are going to receive text. We are going to put line breaks. We are then going to remove any HTML tags. We are then going to strip the output. So strip. And then we are going to return it. So this is the class that will clean our text and will make it ready for us to be used without any noise. And let's also specify the text column. So the text column here is going to be the text column, and the label column is going to be label column name and a text column name, and this is going to be an underscore. So this is going to be jutsu, like this. And let's also clean the text. So cleaner is equal to cleaner. df is equal to text cleaned. And then df dot text column name. So we are going to clean the text column name, which is this text column. Then we are going to apply the clean function on it. So I received an error because we did not initialize the cleaner. So this is how you initialize it, like this. And yeah, so this is the cleaned text right there. Yeah, we can also print out the head so that we do not have too many rows, so only 2. And just like the input of the neural network needs to be numbers, so that we need to tokenize the input so that it can have the output also as tokens, also as numbers. So the output of the neural network needs to be also numbers. And right now the jutsus are in words, they are text. So we need to make a simple map that says ninjutsu is equal to 1, genjutsu is equal to 2, and taijutsu is equal to 3, something like that. And one robust way of doing it, rather than doing it with if conditions, is using something called label encoders that is in sklearn. So you can go back up from here, from sklearn, import pre-processing. Again, if you don't have it, make sure to install it. And you can go back down and initialize it basically. So you have the encode labels, which is equal to LE of pre-processing label encoder, LE.fit, and give it a df dot label columns dot column name dot to list, like that. And this is going to have for each ninjutsu, genjutsu, or taijutsu is going to assign a number. So we received an error here. It says that jutsu does not exist because it is jutsus. So in the label column, we made it. We can make it jutsus. Then we can go back here and run it. I see that jutsus is also missing. So you can see here that jutsus was misspelled from the beginning. So you can go back up to where we tried and did that. So we can just run that again from the start. Make sure to put the jutsus right here and then run it. Then clean, and then the label encoder. Now everything is working fine. So for the label encoder, let's see the results of it. So label dict, and it's going to loop over each of the elements that we have. So for index and label name in le dot underscore underscore dict, like this, and we put classes in, so it's going to loop over the classes that we have fed into it, and then we want to make it toList. Then we can enumerate over it so that we return the index as well as the class names. So this will return the index of it right there. And we can then map it into a dictionary. So like this, have this up and write the index and the label name. And make sure to remove this extra column. And yeah, so 0 is genjutsu, 1 is nenjutsu, and 2 is taijutsu. And this is how we did it. And this is a one-line for loop that returns a dictionary. And a one-line for loop that returns a list is going to be this. So for index in blah, blah, blah. So this is a list and this is a dictionary. Now to transform all of this, all of those jutsus into the numerical type, what we want to do is that we want to have a label column that will have the numerical class, and we are going to run le dot transform and give it the label column and give it the toList, and yeah, this is it. So df dot head, and we are going to have 1, 2s, and 3s all ready for us to start training. Now, one step before that is that we want to divide this into training and testing splits. So what we want to do is that we want to dedicate 80% of this data set to be for training and 20% for it to be testing. And we want to have 80% of the ninjutsu in the training, and 80% of the taijutsu in the training, and 80% of the genjutsu to be in the training. So that we don't have like most of it in the testing and none of it in the training, especially because those are skewed data sets. So we need to take care of that. So one easy way to do it is that we can import a supporting function from sklearn. So from sklearn model selection, import train test split. Then you can go back again down and write df train is equal, and df test is equal to train test split, where you give it the df, you give it the test size to be equal to 0.2, and you give it stratify, and the stratify is going to be the label. So stratify basically tells it to make sure that each of the classes, 80% of it is in the testing and 20% of it is in the training. And instead of putting it like this, 20%, we can also put it like the test size is equal to 0.2, then feed 0.2 right here, since we are going to have some parameters in the class. And yeah, so let's make sure that stratify worked fine. So if you can have value counts, you can find you can just call jutsus right there, and yeah, you can find that 80% of the classes are dedicated to training. Now let's see how we can tokenize output and we can tokenize text so that we can also prepare the text to be fed forward into the neural network. So let's have the model name is equal to, and we have a model name right here. We are going to use something called DistilBERT. Also, DistilBERT is another model that we have. Let's have it DistilBERT based on case. It's also a transformer model. So just copy it, paste it right here. It's also very easy to load with just a couple of gigabytes of RAM that we can load it in. So that's why I'm using it. And we are going to use Llama for our chatbot. It's a very big, so we won't be able to run it locally. And we can have the tokenizer is equal to auto tokenizer from pre-trained and give the model name. And make sure to also import it, so you can go back up. Auto tokenizer is in the Hugging Face library. So from Transformers, which is the Hugging Face library, import auto tokenizer. You can remove the auto sequence classification, and you can go back down, and this is how we load the tokenizer. Now let's create also the function that tokenizes the text. So let's have the pre-process function, which takes in the tokenizer and takes in the examples like that, and it returns back the tokenizer, and we can have the example of text cleaned, then truncation is equal to true. So if something that is above the 512 tokens, it truncates it so that it doesn't break the model. Now we want to run this on the whole dataset. We can do this with the apply function, but we can also do it with the Hugging Face dataset. So go back up and write from datasets import dataset. This might need a pip install, so don't forget about it. And let's convert this pandas data frame to a dataset, a Hugging Face dataset. So convert pandas to Hugging Face dataset, and let's call the train dataset right here is equal to dataset from pandas, give it the train, and we can also give it the test right there. So test dataset, and we can also tokenize it right now, tokenize the dataset. So tokenized train is equal to train dataset dot map. And what are we going to map? We are going to have a lambda function that is going to take examples, then call the preprocess function, give it the tokenizer that we loaded, and then give it the examples like that. So make sure to remove this plus and have the underscore. And yeah, also the last thing is that we want to have it batched equal true, so that if it's out of memory, it doesn't crash because of memory issues. Now let's have the same for a test. So just have the test and test like this, and just run it. Dataset is not defined. I just put it up there and did not run it, so make sure to run it. Come back down and just run this. Now we are ready to write our own text classifier. So the first thing is that we can make the cleaner function. So the cleaner.py like this, and we can go ahead and copy paste it. So scroll up, copy, and paste it right in. So this is our cleaner function, and it's put in its dedicated file so that everything is neat. Then let's create a file called jutsu classifier.py. So let's create a jutsu classifier.py, and you can just initiate the class. So jutsu classifier, like that. Create a init function, and we can make it take some inputs, so some parameters and some inputs, so we can control it with only the init. So let's also have the model path right here. Let's have the data path, which is the data that we are going to train on. And the model path is going to be the output path that we are going to save the model in that we trained. Then we can have a text column name is equal to text, like this. And we can also have a label column name that is equal to jutsu, like this. Let's also add a model name that is going to be the Distilbert model that that I showed you before, like this one. And those are just default values that you can overwrite by simply passing it through when calling the model. Then test size is equal to 0.2, like we did. Then number of labels, we know them to be 3. And a Hugging Face token, that is going to be none. So the Hugging Face token is just the token that Hugging Face gives you so that you can upload data sets to their Hugging Face hub. And yeah, it also identifies you if you have like special access to some models and whatnot. So you can go back again here. And let's put it into the self variable. So self.modelPath equal modelPath. Data path is equal to data path. Text column name, label column name, model name, test size, then number of labels. And then we want to have the device. We want to have it CUDA if torch is available, else it's going to be CPU. And let's also import the torch. Then let's now do a Hugging Face. Let's assign the Hugging Face token. So self.huggingFaceToken equal Hugging Face token. If self.huggingFaceToken is not none, then we need to log in. So we can import Hugging Face hub, and you can have the Hugging Face hub.login and give it the token to be Hugging Face token. And you can remove this token keyword. And just make sure that you have Hugging Face hub in your requirements and you installed it so that it works. Then let's create a function to load the tokenizer. So self.tokenizer equal self.load tokenizer, and have the load tokenizer.self. And now we want to check whether we already trained this model and saved it to the Hugging Face hub. So we're going to use the model path. Else we are going to choose the model name and then train on this. So if Hugging Face hub.repo exists, so if it exists, the model path. If this exists, then we load this tokenizer. Else, we load the tokenizer from the model name, like that. Then at the end, we return back the tokenizer. And don't forget to also import it. So from tokenizers, import auto tokenizer. And this is how we load our tokenizer. Then let's also have this condition inside of the init. So if we see the model path, then if we don't see the model path, then we are going to train it. and then we are going to load it. Let's first check if the data path is provided, and if data path is none, we can raise an error. So raise an error, data path is required to train the model since the model path does not exist in Hugging Face Hub. Then we want to have a function that loads in the dataset. So let's load it in. So train data, test data, equal to self.load data, and give it self.datapath. So that's the data path that we are going to load the data from. And now let's create this function. Define load data is equal to self, and it takes in also a data path. And right now we want to read in the JSON, so read JSON. We also want to have lines equal true like we did before. Lines equal true, and make sure to import the pandas library. So import pandas as PD. And we can also run the simplify jutsu function that we did before. So we can scroll up and just copy this simplify jutsu function like this. Make sure that it has the self, and at the end let's not return anything. So that is, it returns if it just hits the if conditions. And we can run this by just having the same call like the one that we did before. And then we would also need to add the texts like that, like this. Make sure that it is working good. And you can see here that this requires a self, so add it. And then we want to clean the data. I am just brushing over this because we already did that here, and I'm just copy pasting code. So we have the clean text, so just copy it, go back here, and just paste it right in. The cleaner will need to be imported, so you can go back up from dot cleaner, import cleaner. So you can go back down, and for the text column, just write self.text column name. Now we want to encode the labels. So like we did also before, we are going to go back again right here. Just copy this, paste it right in. It would require us to import the pre-processing, and it would require us to have the labels. So we can go back up, and let's get the train test split and the pre-processing and also the dataset. Why not? Go back here and paste them right all in. And this auto tokenizer is duplicated, so we can remove it. Go back down, and now we have the label encoded ready. Then go back here, then see what we did after the label encoder. We have the label dict, so just copy it, and you can delete this. And for the labels, you can just copy this, add it right here, add the self.label column name. And afterwards, we have the train test split. So let's go back again right here and write train test split and just paste it right in. Have the df and have the test size, and call stratify is equal to the label. And after this, we can convert to a Hugging Face dataset and then tokenize the output like we did before. So like we did before, we can convert it. Convert the df train, convert the df test, and have the pre-process function. We don't have it here, so we just can copy it, paste it right in, and add the self init, like this, and make sure to call it with the self function like that. And the tokenizer also has the self init. We loaded it at the top. And that is the tokenized train and the tokenized test. And now we have successfully loaded the dataset. So you can return back the tokenized train and the tokenized test. And I have spotted something here that is wrong. I have read the data into a data variable, and you have to read it in the df variable, like that. So we can go back up, and now we have the load dataset. And afterwards, now because we have a skewed dataset, we need to penalize the function, because we need to tell it that if you made a mistake in Genjutsu, which only has 100 samples, multiply this error by, like, for example, 10 or 20, so that it can focus on Genjutsu more. And at the end of the day, we can have more of a balanced dataset. And skewed datasets are tricky because, for example, let's take this scenario, like 90% of the cancer, lung cancer, for example, dataset is, or even more, like 95 of it, is going to be negative samples, and 5% of them is going to have only the cancer in it. And the model can reach 95% accuracy by simply predicting that all of the samples does not have any cancer. So the idea here is that that model is basically doesn't do anything, and we want to have it focus on the cancerous and not the non-cancerous actually. So we can give it class weights to tell it if you made a mistake with a cancerous sample, then this loss is going to be multiplied by a big factor. So your loss is going to be a lot, and this is what you're trying to minimize. So you need to focus on the cancerous samples and get those right to actually make the model good. And this is what we're going to do, is that we are going to get those class weights and then multiply it with the loss when we have the chance. So let's first get the class weights. And to get those, we can convert the Hugging Face datasets back again to Pandas dataset. So let's have this data df, which is equal to train data dot to pandas, like that. And let's have the same for the test data. And let's put it in one big data frame called all data. So pd.concatenate and give it the training dataset and the testing dataset, then reset index, don't drop index is equal to true, then write class weights is equal to get class weights, and give it all data. Now the idea here is that when we're getting class weights, it's preferred to run it on all the dataset that we have, but we can also run it on the training dataset. So that's why I just converted it back to pandas and concatenated it into one big dataset, because it's preferred to have all the data when we are getting the class weights. So let's now get the class weights. So let's create a new file called training utils.py, and let's create a function called define get class weights that takes in a df and returns back a set of classes. One function that we can utilize for this is that we can have it from sklearn dot utils dot class weights import compute class weights. So this is going to be a function that simplifies for us the calculation, and we can call it by having this. We have it balanced. So we want to have a balanced classes, and the classes is equal to be the sorted version of df of label. So it's going to be the 012 dot unique. We are getting the unique, so this gets the whole column. Then unique gets the unique values. Then we switch it to a list, and then we sort them and put it into the classes variable. And at the end, we give it the column of the df label. So df label like this. Then we give it the column as a list. So like that. And this returns back class weights like that. And we can return it like this. You can go back here and you can import the get class weights function. So from dot training utils import get class weights, you can go back down and you can find that it doesn't have a squiggly line anymore. Then what we want to do is that we want to self dot train model. We want to create a function that has the train model that takes in the train data, test data, and class weights, trains the model, and outputs it to Hugging Face Hub. Then we want to load the model so that we can have the self.load model. We still didn't also write this, but it takes in the self.model path, and yeah, that would be it. So if we don't have the path, we train it right here and save it, and at the end we load it. And if actually we have it, then we skip this if statement, this big if statement that has the training code in it. Now let's write the training code for that. So the training code is going to be a little bit easier. It's going to be just configurations and just like calling some functions that are already made on Hugging Face. So let's do that. So let's define train model. Let's give it self. Let's also give it train data. Let's give it test data. Let's give it the class weights. And let's load the model, which is going to be auto model for sequence classification from pre-trained, and give it the model name and the number of labels. And we can also want to give it the ID to labels. So we want to give it the each label, what ID is going, what is it going to be? So right here, we are going to scroll back up scroll down to the load data. And for the label dict, you can see that it's not used. So let's initialize it right here. And let's put it like this. And the auto model for sequence classification, let's also import it. So it's next to the auto tokenizer. And yeah. So yeah, you can find there's a dot here to make it a comma, and then we can continue. So we need to have a data collator. And this pads the dataset, so data collator with padding. And we need to also encode it, we need to also import it. So let's just copy this, go back here. And in here, we can just do it in multi-line by adding brackets. So adding data collator right there. And we also want to have something called training arguments. Like this. And let's go back down and see how it goes. So this is the data collator right there. So this is the data collator right there. And let's now initialize the training arguments. So training arguments equal training arguments. Then we can close it. And let's just specify the things that we already have like in the initializing function. So output dir is equal to self dot model path. Then we have the learning rate, which is how big the steps are while learning. It's going to be 2, -4. and 2e negative 4. Then per device training batch is equal to 8. And then per device testing batch is also going to be equal to 8. And this is the batch size that I told you about before, that is going to handle big data sets so that it can fit into RAM by dividing it and then training it one by one. Then the number of training epochs, like I also mentioned, what are epochs before, is going to be 5. And this is the number of iterations that I'm going to go through the data set before like quitting the training. Then weight decay is going to be 0.01. And this is essential to make the training at the beginning not lose and not forget the what the model was trained on before. So it makes the changes at the beginning where the loss is very high, makes it less drastic. Then we are going to set an evaluation strategy, which is after each epoch, and we are going to have a logging strategy, which is also going to be after each epoch. And we are going to push to the hub. So at the end, we want to push it to the Hugging Face hub so that we can install it from anywhere that we want. Let's then define the trainer, which is going to be trainer. Right now, we want to define a custom trainer that takes in the class weights and then multiplies those class weights with the actual loss so that it can penalize the classes correctly. So you can go here, make a new file called custom trainer.py. Then we can import torch, then import, then from torch import nn, and from transformers import trainer. And if you're wondering what torch is, it's just a neural networks library, and it's one of the initial ones. There was TensorFlow, and there is also torch, and yeah. So those are the underlying libraries that the models are being trained, being written on. Even Hugging Face uses TensorFlow or transformers to run its models and to train on them. So you can write class custom trainer, then give it the trainer class that we imported from transformers. Then we need to compute the loss, give it the self, give it the model, give it the inputs, and then give it the return outputs as a false. Then we need to get the labels. So labels is equal to inputs dot get and then get labels. Forward pass is going to be like this. So forward. So the forward propagation, and then we follow it back with backward propagation. So the outputs is going to be model, and then we pass the inputs on it. Then we get the logits of the output. Then we compute the custom loss. And we have the loss function as categorical class entropy loss. And we take in the weight. So the weight is equal to, going to be the weight is equal to torch dot tensor, then give it self dot class weights, then to device, then set the device to like this, set the device to device. So we have now a device, and we have the set classes weights that is not in the classes. So we need to make setter functions for those. So the last thing is that we are going to calculate the loss. So we give it, we call the loss function that we initialized above. We give it the logits, and we wrangle the dataset a little bit so that it can fit in. So self.model.config .number of labels, like that. And then the labels is going to also have some wrangling, which is going to be view, then -1. And then we return back the loss and the outputs if the return output is going to be true, else we are going to just return the loss. And yeah, we just need to define the class weights and the device. So those are just simple setter functions. So set class weights equal to class weights and then set it right here. And then we can also set the set device, and this is how we do it. You can close this back and you can go back up, and from here you can write from dot custom trainer import custom trainer, go back down, and we are going to initialize our trainer. So trainer equal custom trainer, then give it the model, give it the arguments, which is training arguments, give it the training data. Let's delete those. Give it the training data, which is going to be the training data. Then give it the eval dataset, which is equal to the test dataset. Then give it the tokenizer. Tokenizer equal to self.tokenizer. Then give it the data collator. Then give it the compute metrics. Compute metrics. And this is a function that computes the accuracy of the model. So we can go back again to the training utils. And here you can just import numpy as np, and then import evaluate. And evaluate also needs to have a library to be installed. So you can go here and you can install it by writing evaluate, which is equal 0.4.2. And yeah, go back again to your training utils and write metric is equal to evaluate dot load accuracy, and then write define compute metrics, then give it the eval predictions. Then from the eval, then separate the logits and the labels. Get the maximum logits as the prediction. Then you can compute the accuracy by running the compute function, giving it the predictions and giving it the reference. And yeah, this is it. So you can just copy the compute metrics. You can go back up, and from the training utils, also import the compute metrics. You can go back here and you can see that compute metrics does not have this squiggly line anymore. Now we need to have the trainer.set device and give it the device, trainer.set class, which is equal to class weights. Then we need to start training, so trainer.train. And then after training, we need to flush the memory. So flush any RAM, flush any unused RAM or unused GPU memory. So this training, by the way, is going to push to hub after it finishes training. So yeah, we don't need to do anything special to save the model. So flush memory, and we are going to delete the trainer, and we are going to also delete the model. Then gc.collect, which is the garbage collection. And you can go back up here and import gc. Then go back down, right there, and then if self.device is equal CUDA, then CUDA.empty cache, we're emptying the GPU cache as well. Now the training code is now done, and what's left is the loading of the model. So define load model, we take in the model path, and we want to import also pipeline, And pipeline is a way for Hugging Face for us to for it to run the tokenizer for us. Then it runs it through the model. Then after the model is finished, it takes the numerical output and maps it to the text output so that we can do this in one convenient function and don't have to do all those steps by hand. So you can call model, then call pipeline, then tell it that it is going to be text classification, then give it the model path, then mention that we want to return all scores, which is equal to true, and then return model. And that is it. We have the load model, we have the train model, we have the load dataset also right there. And the only thing that is left is an inference function. So let's also do that. So let's close all those functions and let's create the inference function. So we're going to call it classify jutsu like this. We're going to make it take itself and a text, which is the text that we want to classify. Then we want to get the model output. So self.model and give it the text. And then we want to have the predictions, which is going to be self.postProcess and then model output. And then return the predictions. So post-process is not there, so let's write it. So define post-process and let it take the model output. And then we can write the output is equal to an empty list. And for each prediction in the model output, we are going to get the maximum prediction, so the maximum score. So label is equal to maximum because we are going to have a score for ninjutsu, genjutsu, and ninjutsu. And the one that was the maximum score, this is going to be the classification basically. So we are going to have the prediction. We are going to give it the key, lambda, x, and then give it the x of score. So that is where the score is stored. And take the label of it. And after we finish, we just create output.append label and then return the output. And this is it. This is the classify jutsu function. And yeah, so everything here is working good. So what I need to do right now is I need to expose this function, this library. So __ init. Like this .py, and we only need to import from jutsu. Let's copy paste it. It's not showing up in the suggestions. So import jutsu classifier like that, and make sure to put the dot. So this is how we expose it. Then we can go back to Gradio and we can write this section. So let's go back to Gradio right here. And let's now just copy paste this again. But now we want to have it text classifications with LLMs. And with row, then column, and then we can write whatever h1 tag we want. So text classifications with LLMs. And then we want to have the output as just text. So text classification output as just a gr text output box. And it's going to have a label of text classification output, and then we are going to give it a path for the model and the dataset path and the text to classify. So let's do that. So text classification model like that. We are going to put in the gr.text box. We are going to give it a label, and then we are going to give it also a model path, like that. We are now also want to have a dataset path, so let's have this. So text classification dataset data path, let's call that data path, and let's call this the data path. Now for the text to classify, we are going to just copy paste it and have it the classify like the text input. Just call it the text input. Now we are going to have a button also for the classification. So let's classify right here text button. Then it's gr button dot classify text. So let's do that. So classify text and then jutsu. And in the text classify function, we need to also trigger it and give it a function to classify on. So classify text, then give it the input, which is text classification model, then the text path, and for the output and the text to classify right there. And for the output, let's have it the text classification, if we can spell it correctly. So text classification as the output right here. Now we don't have this classify text yet, so just comment it and run it. Make sure that everything is fine before we can proceed. So let's copy this, put it right here. Make sure that the text classification looks fine. It does. Now the button doesn't do anything right now, so we can go back, close this, Control C, clear it, and we can write the classify text function. So you can go back up here. You can write define classify text that takes in the text classification model, text classification path, and the text to classify. We can then load in the jutsu classifier, and the way that we're going to do that, we can also have it from text classification import jutsu classifier. The jutsu classifier is going to get the model path, so model path like this, and the model path is going to be this one. Then it's going to take in the data path, and the data path is going to be this one. So make sure that the classification path is correct. And the last thing is going to be the Hugging Face repo, the Hugging Face token. So if you can go back again, you can find the Hugging Face token right there. Just copy it, paste it right here. But what are we going to assign it to? So yeah, before we proceed, this is I think this is the correct one, but just remove this suggestion, and we can get to it later. So where can we find this token so that we can push the model to the Hugging Face GitHub? So you can log into Hugging Face, it's free. Then you can press on this icon and then press on your name, and then press edit profile, press access tokens, and those are the tokens that you want to have. So I am going to create a token for like with you guys. So let's call it tutorial token, and it's going to have write, so make sure to have the write condition on and press create. You can copy this token and press done. So I am going to remove this token after I finish this tutorial. So please make sure to create your own token so that it can work for you guys. And since token is going to be a secret variable, let's also add in a .env file. This .env is going to have the variables that we want to have secret and not push to the Hugging Face basically, or to the GitHub. So Right now, this is going to be the Hugging Face token. So you can go back to your environment and just write Hugging Face token. We can also have a .env example, so you can tell people what to put in the .env folder, because we're not going to push the .env. So you can put it right here, Hugging Face token, and tell people to add it there. So you can go back to your Gradio application, scroll back up, and say from .env import load.env. Then you can call load.env, and what it does is that it takes in all the environment variables in the .env folder and put it into as environment variables. So you can go back here and write os.get env and say that you want to have the Hugging Face token, basically. So this is it. So there's a comma right here that I forgot, and OS is not imported, so make sure to import it. So import OS, and .env here is needed to be installed. So you can go back again to your requirements right here, write Python .env and write equal 1.0.1 like this. So Python /.env and write 0.0 like 1.0.1. Now you can just pip install .env like this, and you can see that to install it you can just have the Python /.env, and that's why I wrote it like that. So yeah, never use your memory to write it down. Just make sure from Google that it's the correct one that you are downloading. So make sure to pip install it, pip install the requirements, and now we are ready to go. So that should be good, yeah. So before we do anything, we need to run the classifier on the text and then get the output. So output equal Jutsu classifier dot classify Jutsu, and then give it the text to classify. And yeah, this is it. So we can run the Gradio application, make sure that everything is running, and then we can test it out on Google Colab. So we got an error right here from text classification. Actually, it's not text classification, it's text classifier. Actually, no, it's text classification. So just from text classification, import Jutsu classifier. So make sure that we are spelling everything correctly. Yeah, I misspelled classifier, but yeah, there's an I here. So yeah, that's why it didn't work. So just misspell this one also so that it works, and everything is good. So let's have it the correct way. So let's have the classifier this way, and then we can open it here, add the I, and we can open also the Jutsu classifier and write it correctly. Go back to Gradio, make sure that everything is good, and yeah, this is good. So you can clear it, run it again, and see how it goes. So this is right now working fine, so you can copy it, paste it right here, and you can see that if you opened up my Hugging Face right here, you're gonna find that I have a Jutsu classifier ready, but I'm going to train a new one from scratch with you guys right now. So let's have a model path, which is Jutsu classifier _2. Then we are going to also have a dataset path, which is going to be the Jutsu JSON L. So copy this path and paste it right here. And let's also add in a description for Jutsu, which is just Rasengan description So yeah, I write Rasengan description and just copy this and paste it right here. Where is it? Yeah. Just copy and classify. So yeah, we got an error. So let's see what it is. So I fixed a couple of stuff. In the self.label column, here it was jutsus, and also here it was jutsus. So just replace it with label.column name. And then in the per device testing batch size, make sure that it is eval batch size, so it's eval. And in the end, it was here training data. In the custom training, it was training data set. So now it's train data. So yeah, that is it. And one more edit in the custom trainer, just in the logits, make sure that it's you add this line, logits equal logits.float, to convert this into a float. So yeah, you can just save it, go back to Gradio and clear it, run it again. Go here and press classify jutsu. And yeah, so right now you can see the outputs right here of this, and it will run for a while. So yeah, we need to move this to Google Colab and train it there. So let's close this down and train it. Since it's now working locally, I can now start and push it to GitHub and then pull it and run it on Google Colab. So you can write git status, and you can find that we have a couple of edits in Gradio, requirements, and we also have classification that needs to be pushed. So let's just have the diff of get Gradio app. Make sure that nothing's weird going on. So everything is looking good. Just git add this, then git status, see what's up, get the git add the requirements as well, then git add the text classification, git status, and yeah, so those are all the files that we want. We can also add the .env example, so git add .env example, and you can just git commit -m add text classifier, git push, and let's now go to the Google Colab, and you can go here and you can just run it. No need for us to pull, so just install the requirements and install the Scrapy requirements. We won't need it for the text classifier, but just in case we want to run it. And now, if you remember, we have a .env file that we did not push, so we can push it and make it here on the terminal side. So you can just have here cd analyze series with NLP. Then you can just have the environment variable created right here in the terminal. And we can just echo the Hugging Face token right there. So you can just copy it, paste it right here, make sure to put it between quotes, and then you can say that we want to put this in the .env file, and you can run it, and this will create a .env file, and it will have one line which is this environment variable, and yeah, we can then run the Gradio application. So yeah, it will take a while for it to install the requirements, so I'll cut the video and come back when it's done. So it's now finishing, so you can add a new folder, call it data. Then inside of the data folder, you can just upload the JSON-L that we have. So go to your data, you have the jutsu.jsonl. just upload it. While this is being finalized, it will upload the dataset. So you can just copy this, paste it right in. Right here you can find the data. Jutsus has been updated, so you can just copy the path, wait for this to finish, then paste the data path right here. The model path is going to be, so I have a model path right here. When I was preparing for this tutorial, it was Abdullah Tariq, which is my name, then Jutsu classifier. So I won't overwrite that, but I will make a new one for you guys, so we can start from scratch. So I will have Jutsu classifier _2, and then the text is going to be just the Rasengan description, which is one of the ninja attacks that we are trying to classify. So just write Rasengan description and it will appear to you guys here. Just copy it, paste it right in, then press classify jutsu. And yeah, if things don't break, then it would take a while for it to finish, to train the model, then push it to Hugging Face, and then it will load it back in, and then like run this text classifier input on it. Yeah, and yeah, so I will return back when it finishes, and see you then. So now it's finished, and you can see the output here is in the list. So we'll need to make that of 0, so to get the first one. But other than that, everything else has worked fine. And you can go back to your Hugging Face, refresh the screen, and you can see that we have the Jutsu classifier _2, and it correctly classified the Rasengan as a ninjutsu, that is the correct thing. And yeah, you can go back to your Jutsu classifier, you can go to your files and versions, and you can see all the tokenizers and the weights right here uploaded for you guys. And you can download it normally. So the one that I will keep is, I will keep the Abdullah Tariq Jutsu classifier model. I will remove the _2 because that's just a duplicate. So yeah, so if you want to remove it, just go here and I understand and delete this model. Also, one more thing to note, that if you run into any issues or any training issues that you have here, mostly you're gonna find that it will save the most up-to-date model. So when you run it again and you are trying to pull this model in, it might give you an error because not all the files has been uploaded. So make sure to go and delete it and then start from have a fresh start. So you can delete this model, and I am keeping for you guys this one, so if you want to play around with it. So yeah, make sure to use this one and not the _2. So yeah, we can go back again locally from here, and you can go to Gradio again, and go to your text classifier, make the output as output of 0, because now we were returning a list. And one more thing, let's run it locally and see how it goes. We won't train it, but we would just make inference on it. So you can clear this, get status. We have one edit, which is the .0 that we made. So let's add it here. Make the output, make output as string, not list, commit, then push. We don't have to train again since everything works fine. It's just this small thing. So you can just run it right here. Wait for it to launch. And there you go. So just copy this. Go back to your website or browser. Just go to your text classification and paste in the model that you have, which is Abdullah Tariq, whatever you want, like the Jutsu classifier one. Then you can just add the text input, which is, we had the Rasengan description, and like this. And you don't have to provide a data path since the model path already exists. So you can just classify the jutsu, and it should be there. So yeah, you can see that it finished quite quickly, and the output is ninjutsu, and everything is working fine. So now we can move on with our next module, which is the character chatbot module. So the character chatbot module, I'm going to show it to you guys. This is the module for the chat for the Gradio. All of it is like ready-made. So you can write whatever you want here, and depending on the character, it would like act as the character and like copy his behavior and his response behavior, and then respond to you as if it is this character. So yeah, so you're just imitating as if you are just chatting with the character that you like from your series. So I'm going to write, what's your dream? So you can see now we have some good animations right here. You have the your message, and then the output message from the chatbot is going to be right here, and you have a loading screen right there. So everything right there is ready made from Gradio, so we won't need to do it from scratch. And yeah, the response takes a little bit of time because every time we load a huge model in RAM. And if we're doing it on production, this model should be always on RAM, but I wanted to make sure that we have enough memory to run the text classification, the character network, and the text and the theme classifier. So after each run, I just like inside of each function, I just initialize the model, and then at the end of the function, this model is going to be put into the garbage collection so that it can free up some space for the other models to run. And yeah, I'm going to wait a little bit for it to finish, but afterwards I'm going to show you the output, and then we can code it together. So now it's done, and you can see that it responded like it's Naruto, and its dream is to become Hokage, which is actually Naruto's dream. And yeah, this is it. For this model, we are going to be using one of the state-of-the-art models, and it's a big one. It's called Llama model that is from Meta. And yeah, it competes with ChatGPT and competes with state-of-the-art models. And it's also in the leaderboard, so this is one of the state-of-the-art models that we can use. And we are going to use it for chatting with a character, and you can have as many, by the way, you can have here as much messages as you want. You can then respond and then build on these messages that are from above. And yeah, it will keep on piling up till till it has like the memory limit, and then it will truncate any messages that is above it. And yeah, this is it. We are going to be using Meta Llama 3 8 billion parameters instruct tuned, and this one is going to be it needs to have access. So if you just go here, I'm going to show you also what it looks like if you don't have access to it. Right there, it would tell you that this is going to have a license agreement, and you need to log in and then press on agree or something like that here, and then it would give you like this. Like it will be like this, so you have been granted access to this model. It might take a couple of minutes for you to get granted access after you press the button, but afterwards it's going to be good. And we are going to use the same token that we have, and the token, the Hugging Face token that we have, is going to see that we have access to the Meta 8B instruct tuned model, so we can download it easily. So let's move again to the code, and let's clean up all this. You can close down all this, close it, and close all this, like that. Then we can create a new folder called, new folder right there, called character chatbot. So character chatbot, and inside of it, let's create a notebook that demonstrates how we are going to wrangle the data and what data do we want exactly for this character chatbot to work. So we can just write character chatbot development.ipynb. Then it would ask you to add the Python environment variable. Here it didn't, but it might. And we can just import pandas. And yeah, you can just load the model, start loading the model. So load the data, sorry. So load data or model data set like this. And the dataset that we are going to use is going to be the transcripts dataset, which is the Naruto.csv. I'm going to show you it. So pd.read.csv, then we can go back like this, data, and then write Naruto.csv. I don't know why it's not coloring, so let me, yeah, so it's a text, it's a markdown cell, so you can just add code cells, put it right there. Now you can have as PD, then you can run it like this, df.head, and yeah, you can see this right now, which is going to be the name and then the response of the character. So this is the character is talking, but there is also some sort of action that is in between brackets. So we'll need to remove those, since a chatbot does not output actions; it only outputs text. So we'll do that using Gradio, which is a way to select characters or like a sequence of characters based on some rules. And yeah, so we can go ahead and write, let's call this Naruto transcript. Transcript.df, and let's put this into a data path. Then let's just copy it, put it right there, and let's have the head right here. Afterwards, let's write the code to remove those everything that is between parentheses. So let's just copy it. So let's just have a remove actions from transcript, then create the function which is remove parentheses, then give it the text. And right now the regex library that we are going to use is called re, so this does not need to be installed. I think it's in the default Python libraries. So you can have the re.sub, then open up R, which is going to be regex, and we are going to say that everything that is in between brackets, so starting with a bracket, then dot, that means one or more like any character that we want, then it's going to be a star that says this is going to be 0 or more characters, and then like a question mark that says this might or might not appear, then followed by a parentheses. So this is basically telling you this, and it's telling you that anything that starts with a bracket, has any characters in between, and then ends with a bracket, this is going to be selected by the regex expressions. So yeah, so you can just say that we want to replace this with an empty string, and then we want to process this on the text variable that we have right there. Then we return back the result. Now let's process this on all of the lines here, all of the rows. And the way that we're going to do that is that we are going to also use the apply function. So let's have the line where Naruto of line.apply, then remove parentheses, then run that. So the line here is capital, make it small. Just make sure that, yeah, I think it is. Just run it. It's now working, so you can just have the head of 2. And you can see now that we had this laughing and this turns away. Now we don't have it here, so everything is working fine right now. Afterwards, what we want to do is that let's remove this 2 and let's only choose the Naruto. We want to choose the Naruto responses, and we want to make sure that it's not something that is very small like moi, like this. We want to have at least like an X number of words so that we can see like characters, like the Naruto's or the character's personality in those words. And yeah, so we want to have also Naruto responding, so we are going to exclude the first line here, and anything that is below that, we can just take it. So let's have this, so let's write those words, and let's first count the number of words per line. So we can have the Naruto df, let's count the number of words, so number of words, which is going to be equal Naruto.line apply. Then what you want to do here is not apply. I'm going to show you another way, but we can do it through apply also. Right, str, which is basically a string, then split, and this is going to split words from each other. Then you can write str again, just make it a string. Sorry, this is going to be strip, and then split it, and this is going to be a space. So right now we are going to put in the number of words a list of words basically in the line. Let's also now count it, so we can count it through apply. So you can have Naruto df of number of words like that here, and you can have dot apply, then lambda x, and then have the length of x. So make sure to just have this one as a dot, and you can run it, and now we can see the results. So just copy the head and then paste it here, and you can see that it now counts the words quite correctly. So we can now create another row, another column that is called Naruto response flag. So that's going to be just a flag that tells us whether or not we should take this row or not. So we can just have it like that, which is Naruto response df, and we are going to have the Naruto response flag, and let's set all of them to 0 right now. And afterwards we can just lock, which is location, like we can find the location of, and give it the Naruto df like this of name, which is going to be equal Naruto. So the name is going to be equal Naruto. So we are going to take the rows where the name is equal to Naruto, then make an and also take the Naruto df where the number of words is equal to 5, at least 5. So number of words is going to be greater than 5. And then what we want to edit is the Naruto response flag. So just put it right there, then write equal 1. So anything that has the Naruto and also has the number of words greater than 5 is going to be equal to 1. So just copy this Naruto transcript df right there, and right here you can have, like, you can see that this is 1 and this is going to be 0 because it has one word only, and yeah, so on and so forth. But the only thing that is left right now is when we're picking the indices to choose, or the row indices to choose, we should exclude the first row because it's not a response, it's just like initiating conversation. So we can write here indices, like indexes to take, and we can just have a list of Naruto transcript of going to be Naruto transcript again, like that, and we are going to put the Naruto flag. This one is going to be equal 1, and we are going to also set the index to be equal, like greater than 0. So we can just write it right here. So Naruto df dot index is greater than 0. And yeah, so this is it. And at the end, we just want to get all the index of this data frame. So just run it, and we can see the indexes to take. Just put the first 3, and those are the first 3 indices to take. So right now we want to create the prompt that we are going to feed through the chatbot. So we are going to give it the system prompt that introduces it to the task, that it is going to act like Naruto, and Naruto is from an anime character, and so on and so forth. Then we are going to give it the question or statement that is set to Naruto, and then we are going to give it Naruto's response. And this way, the machine would understand how Naruto is responding to multiple questions and multiple statements, and though it can imitate it. So let's build that right now. We can build the system prompt, and we can write something like this: you are Naruto from the anime. Then write Naruto like this. Then tell it your responses should reflect his personality and speech patterns. And yeah, that is it. At the end, just put a new line. And yeah, we can just go ahead and give it the what was Naruto being said before that, whether it's a question or a statement. So you just have the prompts that we are going to use, and run for each index in indices to take like this. What we want to do is we want to initiate the prompt as the system prompt, and after this we want to add we're going to add what Naruto was being what was being said to Naruto. So just take in this, like here, write iloc and then of index -1, and then what we take is we are going to take in the line, so the line column. Then what we want to do is we want to have a new line. So let's have this right here. Then plus equals, and then have it as a new line. Then have the prompt like that. Then plus equal, and then put Naruto's response. And Naruto's response should be dot iloc, and don't forget the C right here, of index, and then it's going to be the line column. And afterwards we just add this prompt to the prompts list that we have, and this is the data set that we are going to use. And let me display to you what's the one of the data sets looks like. Let me print it out so that you can see the new lines. So this is going to be the system statement, and this is what was being said to Naruto, and this is Naruto's response. And you can have another one, and you can have this one. Yeah, so you can have also multiple you see you have multiple situations where you can see Naruto's response. So you can just print it out and yeah, see how it goes. So before finalizing this, just put it into a pandas data frame and then put it into a Hugging Face data frame so that we can also train on it. So you can just write pd.dataframe, then give it the we can give it from the text instead of that. So you can have this, give it prompt, and give it also the prompts list that we had above. And then we can have the df.head, and you can see that here's are the prompts that we have. And right now we just want to convert this into a Hugging Face dataset. So you can go up and write from datasets, import dataset like this, and this is the Hugging Face dataset, and you can go back down and you can write dataset dot from pandas and give it a df, and then just write dataset right there. So now we're done with the data wrangling, and now we want to create the model, train it, and then use its inference. So we are going to jump to the .py file, and training the model is going to be also some arguments that we want to pass, but the logic itself and the code for training is going to be on Hugging Face. So yeah, we won't have to do any heavy lifting here except for the fine tuning and the parameter tuning. And we are going to do one more thing in this model, which is this model is huge and it does not fit into either my RAM or the Collab's RAM. So we want to have it, we want to have some hacks so that it can decrease in size. One of those hacks is that instead of each weight number taking 64 floating points, like 64 bits, we can make it take only 4 bits. It would lose some accuracy, but it would fit into memory. And also we would have a faster way of training, which is called LoRa. And this adds in a couple of weights to the model that fine tunes it and learns the what the task is. And then it enhances the model accuracy on this task. And yeah, it's a faster way to edit, like to train those large language models. And we are going to be using both. So just save this notebook. You can go back to character chatbot and you can create a new file that is called character chatbot.py. Then you can just write here the class, which is going to be character chatbot. Then you can write the define init like that. Then add the self and add the model path. Then also add the data path, which is going to be the data path that we are going to have on Collab, because like you saw here, we don't have the option. Whoops, it's not that one. It is going to be this one. So we don't have the option to input any more data, like the model name or the dataset path. We only have the place for the messages. So we are going to write them here as inputs. So let's go back to the data path and write just content /content/data, and then we are going to put the Naruto.csv in it. Make sure to edit this path if you are having a different model, but otherwise you are good to go. And yeah, at the end we want to have a Hugging Face token. So let me get it from here, the Hugging Face token, and we can initiate it with none, like that. So that's the init. So let's have the self.model path equal model path, the usual stuff. Then data path is equal to the data path. And then we want to have the Hugging Face token equal the Hugging Face token. Then what we want to have is have a base model path. And this is the original model that we are going to train on. And if you opened Llama here again, like the Hugging Face again, and you just copy this path to the Llama model, and we can paste it right here. Then we can have the, of course, self.device, and it's going to be CUDA if Torch is available, not if it's going to be CPU. And we can have the import Torch right here. Then let's continue on. If we have the Hugging Face token, so self.Hugging Face token is not none, like that. Then what we want is we want to log in to the Hugging Face hub. So let's import the Hugging Face hub. So import Hugging Face hub right there. Then go back down, right, Hugging Face hub dot log in, and you can give it the self.token dot Hugging Face token, like this. And then we want to see if the like the model that we have, the model path that we provided exists. So if it exists, we just choose it. If it doesn't exist, then we train it, save it, and then use it, just like we did with the text classifier. So if, whoops, sorry about that, go back here. If Hugging Face hub dot repo exists, then we can see which repo we want, which is going to be the model path. Then else, here we are going to load the model. So self.model is going to be self.load model, and then give it the self.model path. Else, what we want to do is that we want to train it and then load the model. So let's have it here like a print statement that is called model not found in Hugging Face hub. We will train our own model. Then we are going to have the train dataset, and we are going to have the self.load data like this. After we after we load, we then train, and then after training we load the model. So load model. Of course, we don't have the load model yet, and we don't have the load data yet. So let's create those and then come back to training and then loading the model right there. So let's start with the load model function. Load data function. So define load data and give it the self, and then we can just copy paste most of it from our notebook. So you can scroll back up and you can read it first. Pandas is not imported, of course, so make sure to import it. And let's create a space right here. Then this dataset path needs to be self.dataset path. Afterwards, let's drop any NA, so drop any NaN values, and then we can apply the same functions that we applied before. So we can just copy paste this right there and import 3. So this is the function that removes the parentheses, and we can go back here and we can just remove the parentheses like this. Then we want to calculate the number of words. So the number of words is going to be those 2 lines. Then we want to have the response flag. So you can go back down and see the response flag that we have right there. Then we want to choose the indices to take. So let's choose the indices right here. And afterwards, we are going to build the prompts like we did before. So just copy it, paste it right here. Make sure that the indentation is correct, like this. And yeah, so right now this is correct, and we can just add it in the df and make it a pandas data frame, and then make it as a Hugging Face dataset. So like just like we did before, we don't have to write it. I was going to, but we already have it. So I wrote it here, and then you can just like create it as a dataset right there and return back the dataset. Of course, the dataset is not imported, so make sure to import it first. So go back here from datasets, import dataset, and now the load dataset is done. And afterwards, we just want to have the train function. So let's have the train function and then continue with the load model. So go back here and write define train, and it's also going to take a couple of parameters. So it's going to take the self. Then it's going to take the model name or path, which is going to be this name, which is in the Hugging Face name, this one. Then you can write the output directory where you can save your weights. And you can have the per device train batch and set it equal to 1 because it's a huge model and we might not have more memory for like a bigger batch. And we want to have also the eval batch is equal to 1. And then we want to set the optimizer, which is going to be paged Adam W 32-bit, and this is a little bit lightweight on memory on CPU. Then we can have the save steps, and we can save every 200 steps. And afterwards we want to have the logging. So logging steps is going to be after 10 steps. So logging steps is equal to 10. Then we want to have the learning rate. Learning rate is going to be equal to 2e-4. And let's have the max grad norm is equal to 0.3. Then let's have the max steps is equal to 300. Let's only make 300 iterations. And let's also have a warm-up ratio. Ratio is going to be equal to 0.3. And last thing is going to be the learning rate scheduler type. It's going to be constant, so we don't change it over time. And yeah, this is going to be the training arguments. It's a lot, but it's all what we are going to need. And like I said before, we are not going to load the model like normally. We are going to make it 4 bits and then load those so that it can fit into memory. So we are going to lose a little bit of accuracy from this, but it's going to fit into memory and we don't have to look for bigger machines or something like that. So for that, we are going to use something called bits and bytes config. So let's import it first. So you can go back to transformers, like from the input. So from transformers import, then bits and bytes config. We want to also put the auto model for casual LLM, and this is the casual large language model, and then also import the tokenizer. Then we can go back down and start initializing those. So we can have the bits and bytes config, and then we can have the load in for bit, which is equal to true. So we are going to be loading only 4 bits, and then we want to specify what algorithm we want to have it to make it 4 bits. And so for that, we are going to have BNB. Then specify the quant type. It's going to be NF4. And we also want to have the compute D type, which is the computation. When we're doing computations, what is the data type that we are going to use? We are going to make it 16 bits for that. So let's have the compute D type, which is equal to torch dot float, and it's going to be 16. And this is the bits and bytes config that is going to make the model weights 4-bit instead of 64 or even 32. Then let's initiate the model. So you can have the model equal auto model for sequence classification. Then we can give it the base model. And after the base model, we want to also give it the bits and bytes config. So it's called quantization. Quantization config equal BNB config. And the last thing is that we want to trust remote code code equal true, and let's not use any cache if we have it. So let's have it get it from the Hugging Face hub if it can. So config dot use cache was equal to false, and then let's import the tokenizer. So tokenizer is equal to auto model tokenizer dot from pre-trained, and then give it the base model or name. I think I've misspelled it. Yeah, so it's called model name or path. Let's call it base model name or path. Just copy it. Make sure to put it in the pre-trained when we're loading the model, and then make sure to also have it in the auto model tokenizer. And I think I copied it wrong, so copy it, paste it right here, and also paste it right here. So you can go to a tokenizer, and we also want to specify the padding token. So you can have the padding token is equal to the end of statement padding token. And now we want to have the LoRa configs that enables us to have some weights, additional weights next to the model that is going to be trained and is going to enhance the model abilities instead of training the full model and taking a lot of time and also resources. So let's have the LoRa alpha is equal to 16. Then we are going to have the LoRa drop out, and it's going to be 0.1, and a LoRa R is going to be 64. And for the LoRa config, we need to install something in the requirements that is called PEFT. So you can go back again to your Google, write install PEFT, then go to the first link, which is the Hugging Face link, and then you can find here that it is installing it using Git. So you can just copy it, paste it right here, like this, and you can write .git afterwards. And then it also requires you to install something called TRL. So TRL is equal then 0.9.6. And also we need to also install the bits and bytes config. So bits and bytes, and also give it the 0.43.3. Those are the exact ones that I'm using. So just save it, make sure that you install it. So right here you can just clear this and pip install requirements, actually -r requirements. Make sure that to have all those libraries in. And you can also have the LoRa config right here. So we can go back up and import it. So you can have from PEFT import LoRa config and PEFT model, and also from TRL import SFT config and SFT model and SFT trainer, sorry, like that. So this is what we're going to use here. So you can scroll back down and in the LoRa section, and we can start initiating the LoRa object. So from here you can have the PEFT config, which is equal to the LoRa config, and then basically give it the things that we initiated above. So LoRa alpha is equal to LoRa alpha, and then LoRa dropout is equal to the LoRa dropout. LoRa R, so this is just called R here, so it's going to be equal to the LoRa R. Then have the bias is equal to none, and then have the task type is equal to casual LM. And yeah, this is how we initiate the LoRa configs. Then let's initiate the training arguments, and for that we can have the training arguments, which is equal to the SFT config, and we are going to specify the output dir as the output dir per device train batch is equal to the per device train batch size, and then we have the per device eval batch is equal to the per actually we don't need this, so we are going to have the gradient accumulation steps, which is gradient accumulation steps is equal to the gradient accumulation step that we have above, and we don't have it above, so just have it right here. Gradient accumulation steps is going to be equal to 1, and this eval we don't need, so you can just go back here and just paste it right in. Then you can specify the optimizer equal to the optimizer, and then you can save the specify the save steps. Let's close the bracket so that it lets us have the autofilling. Save steps, then logging steps is equal to the logging steps, learning rate is equal to the learning rate, fp16 is equal to true, so we are going to make this floating point 16 to fit into memory, and then we can have the max grad norm, and then we can have the max steps, then we can have the warm-up ratio, then we can have the group by length, just to make the training more optimized, to have the similar length closer to each other. Then the scheduler type is going to be equal to the scheduler type, and we already have all those defined in the parameters above, so that's why I'm skimming through them. Then report to, and then we are going to report to none. We don't need to report to anything like weights and biases and things like that. Make sure to have this as the correct bracket, and yeah, I see no more squiggly lines, so we can proceed with that. So after this we can have the max sequence length is going to be equal to 512, and then we are going to have the trainer, which is equal to the SFT trainer, and we can give it the model equal to the model, then the training dataset. So let's have the train dataset is equal to the dataset that we have. Dataset doesn't seem to be here, so let me scroll back up and see if we have it. So we don't, so just have this data set like this, and let's continue from here. Then it's going to be peft config is equal to the peft config, data set text field is equal to the prompt, and this is the prompt column that we had. Max sequence length is equal to max sequence length, and then tokenizer is equal to the tokenizer as well. And the last thing is going to be providing the arguments, which is equal to the training arguments that we specified above. So after this we just train, so trainer.train, then we want to save the model locally, so save model, then trainer.save model, like that. Then we want to have it in final CKPT, and let's also have this for the tokenizer, so let's save the tokenizer also. Then we can just flush the memory, and the way that we are going to do that, we are going to delete the trainer, and we are going to delete the model. Then we are going to garbage collect, so GC is not installed, is not imported, so we can go back up and write import GC, scroll back down, and gc.collect now is done. So we can have so now we just want to read the model, then add to it the CKPT weights that we saved, and yeah, so from here actually I did a small mistake. So trainer is trainer.model dot save model dot save pre trained, like this. Then for the tokenizer, we can also run the save pre-trained on it. Then for here, we just want to have the base model, which is equal to the auto model for sequence for casual LLM. Then we write from pre-trained, then give it the model name or path. Then we make sure to return dict is equal to true. Then we can have the quantization config is equal to the BNB config. Then we can have the torch type, torch d type is equal to the torch float 16. And then we can have the device map is equal to the self.device that we have, like that. And yeah, this is the base model. So afterwards, we want to also load the tokenizer. So let's have the tokenizer equal to the auto tokenizer from pre-trained, and then give it the self.base model path. And we can also have it like the one that is we sent to it. So it's called base. I think it's going to be the same value at the end, but we are passing this value to the function, so why not use it? And then we have the last model is going to be the PEFT model that we have, that we imported. Then from PEFT model, just write from pre-trained, then give it the base model that is going to be the one that we didn't have any edits on. Then you can give it the path that has the trained model, so that it can combine both together. Then you have the model dot push to hub, and then write the self dot model path. And right now we are going to push this to the Hugging Face hub so that we can download it and use it quite easily. And at the end, we want to have the tokenizer also pushed to the hub. So this is how we do it. And then at the end, let's just delete and the model and the base model. Base model. And also gc.collect. We don't need to do it here since we are already like finishing the function. But yeah, just a good practice to have this. Let's also have a comment like that. And now we are done. So what's left here is that after training, we need to load the model so that it can be used. So if you go back up to the I am concerned that those are not being used. So you can see that there's a squiggly line here, and I have missed a comma right there and right there. So you can just save, and you can go back up. All of them are used right now, so all good. And right now we have the load model and train model. So we can write the train model first. So self.train, then give it the self.model base model path, then give it the train dataset. Then at the end, we can load the model, which is going to be self.model equal to self.load model, and also give it the self.model path that we have. And yeah, right now we just need to write the self.load model. And also the model will not fit into memory. So what we need to do is also copy paste the bits and bytes config. Just copy, paste it right here. and then we are going to also have a pipeline so that we don't have to tokenize and then like run it to the model and then convert the tokenized numbers into words and so on and so forth. So we are going to use the pipeline here. So go back up, make sure to import transformers. We are not importing it, so import transformers. Go back down, make sure to have the transformers dot pipeline. Then say it's text generation this time. Then we want to have the model equal model path, which is the path that we already trained and pushed to the model, like the Hugging Face hub. Then you can have the model keywords or keyword arguments, and it is going to be the torch. D type is equal to float 16. Then we are going to also have the quantization config is equal to the BNB config. And yeah, this is it. At the end of this, we just want to return the pipeline, and the load model is now done. Now the last function that is left, which is going to be the chat. So just take this pipeline and run it through the input that it's giving to you. So you can have a define chat that takes in self messages, so the message, and then it takes in the history, which is a list of messages with the history. So let me show you what history is going to be. History is going to be like this. So it's going to be hi, how are you? And this is going to be from the user. And the second one is going to be from the system. So I'm fine. I am system. And then we are going to have two more. So it's going to be like this. So it's a list of lists where the inside list is going to be two strings only, one from the user and one from the system. And this is how actually like Gradio like wrangles this data and puts it into this convenient format. It's ready made for us, and it's ready for the chat system. So we'll have to wrangle it a little bit. So you can have messages equal to an empty string. Then let's add the system prompt, add the system prompt, and we can have it as messages dot append, and you can write the same Naruto system prompt that we had right here. You can delete the first space, copy this, and then come back here and append it. Then for message like this, and response in history. Then what we want to do is that we want to append the messages. Append where role, we are going to add it as a dictionary. So where role is going to be equal to the user. Then the content is going to be equal to the messages and response of 0, like that. So this is going to be the messages where the role is where the messages from the user. Then we want to have the message from the assistant. So it's going to be assistant like this. And like I told you, it's going to be 0 and 1, where 1 is from the assistant and 0 is going to be from the user. And afterwards, we want to append this to the, like this is all appended to the messages. And at the end, we just want to append the final message from the user, which is the current message. So messages like this, dot append, then give it the role of user, then give it the content, which is going to be message. So just paste it right here. And yeah, there is an issue. So the issue is in the indentations. I think there is some weird stuff with the indentation, so just I'm going to fix it. So it's right here, right there, and I am going to have it like this. So everything is working fine right now. And we can also add terminators, like if the model outputs any of those, it can terminate the generation. So it's going to be self.model.tokenizer, and it's going to be the end of sentence token that is normal. And the other one is going to be also an end of sentence token, but we are going to convert it. So convert tokens to IDs, and also give it here the end of sentence. So it's going to be something like that. EOT_ID. So those are two end of sentence tokens that we are going to generate. And at the end, we are going to just run this through the model. So self.model, then give it the messages. So messages, then pass in the maximum length. So maximum length is going to be max length is going to be 256. We don't need a huge output response. And then we want to have the end of sentence token ID. So EOS token ID, which is equal to the terminators, and then do sampling, which is equal to true. So every time we run the same thing, we can have a little bit of the different response. And the temperature is going to be 0.6, and we are going to have the top P is equal to the 0.9. Temperature is basically how random the output should be, and 0.6 is around the half. So yeah, this is going to be like pretty controlled randomization. So output message is equal to the output of this, going to be 0, then going to be the generated text, then we have equal to -1. Like it's going to be, we want to only get the output at the end. So output here is miswritten, so make sure to have the correct output, and then return the output message. And we are now done. So the chatbot system is now done, and we can have the init .py, then say from character chatbot like this, import character chatbot, and then we can go back to Gradio and write the UI for that bit. So go back to the Gradio application, then scroll down, and in here you can have the character chatbot section, and we can have with gr.row, then with gr.column, then we are going to have gr.html, then we are going to have the h1, the normal h1 tag that have the title of the section, and we are going to write the character chatbot, and then we want to have the gr.chat interface, and this like builds the whole chat interface, and we just give it the function. So chat with character chatbot like that, save it, and then you can go back up and write this function. Go back up here and define .character chatbot. It takes in two things. It takes in a message and history, and actually Gradio is who's like, it's providing the message and the history, and it's keeping the history in memory, so that every time it calls it, it like gives you the whole history in. And this is pretty cool so that you don't have to have this logic in. And you can first like initiate the character chatbot. So character chatbot is equal to the character chatbot. So let's import it. So from character chatbot, import character chatbot. Just copy this, come back here, paste it right in, and say that you want to have this. I already have also a model that I used while training, while preparing for this tutorial, and it's called Naruto Llama 3B. I am also going to train one from scratch with you guys, so it's going to be _2. And I am also going to provide a hugging face token like the one that I did before. So just copy this and paste it right in. And now we can have the output. After this, we can have the output character chatbot.chat, then give it the message, give it the history. And then for the output, we want to have the output of content dot strip, and then return back the output. And yeah, this is it. The only thing that concerns me is this squiggly line. So just maybe copy this, make sure that it has the correct spelling, make sure that this also has the correct spelling, copy this, put it right here. Then character chatbot, make sure that it also has the correct spelling right there. And everything seems to be working fine. I think the squiggly line will go away after some time. So just save it, then get status, get add. We can add Gradio, the requirements. We can also add the character chatbot and get status again. And this is it. Also, I can see that there's an edit that happened on the Python notebook for text classification. So you can just get the diff, see what it did. You can actually not see much from the, yeah, you can see this. So yeah, you can just add it and git commit -m character network character chatbot, then git push clear, and now we are good to go. Let's go now to the to here, and we did not close it, so that consumed a lot of GPU time that we actually needed. But yeah, let's stop it, then let's go back up. So you can go here, you can just manage sessions, just close this, terminate, and have a fresh start. So you can clone this, then install the requirements like that, then install the like the Spacy requirements, then have the token, and also have the Gradio application running. Also, it's going to take a little bit of time to initiate, so I'm going to cut the video and come back when it's done. So now it's finalizing. While it does, just create a new folder called data, like this. You can also upload the Naruto dataset. So you can have here, upload the Naruto.csv. And you can see that we also have an error right there, which is cannot import character chatbot. And this is what I feared. This squiggly line means something. So from here, you can have the character chatbot. Let me make sure that the spelling is correct. Character chatbot. Then the init.py is also might be correct. So let's have this character chatbot. And let's also get the naming for the character chatbot correctly, like this. And here, let me write the character. So the character chatbot was misspelled right there. So this B was small case. It should be uppercase. And you can just copy it. It still has the squiggly line, so I'm not So I don't think that I'm off the hook yet. So you can just save it, get status. You can see that Gradio right here has the edit, so you can add the Gradio, get commit -m, fix the chatbot, and that is it. Git push. Then we can go back up here. We can, I think it has an error, so we don't have to stop it. Then we can just pull that. We don't have to install the requirements again since we didn't add anything to the requirements. Go back again to the Gradio, just run it. So now it's working good. So we can just copy this URL and paste it right in. And we want to have this data. So this data is in place, so we just have it. And we do not provide it, so it's going to be like it is fixed in the parameters of the character chatbot. So I can just write, what's your dream? And right now, let me go back here, and I have written that I needed to push this at Abdullah Tariq at Naruto Llama 3 and _2. I am doing an _2 to train it with you guys. So you can have this also right there. I have the _2 because I started before, so let me delete it. Let me delete this. So you can go back here. You have this while I was doing it with like the previous preparation for the tutorial. And now I don't have the _2. So it should start training from scratch. And yeah, so let me submit it and see how it goes. So you can go back here and see the logs that it is now trying to download the model. So I can cut the video and return back when it's done. So I got an error that as the quantization error config does not exist, and I think I missed an A here, so it should be QUA. So go back here, go back to your character chatbot, and make sure that you're training the model. And in the quantization, let me go back, let me go here. In the quantization config, where is it? Yeah, right there. So it's quantization config. And we are going to pass in the BNB config. So this one. So let me just make sure that the spelling is correct. So it's QUANTIZATION. Then it is _config. Then it's BNB config. So just save it. Get status. Go back to your git add, then git commit -m, just write fix chatbot, git push. Then you can go back here, stop this, and you can run git pull. It's now pulled. I think it has, yeah, so it's now pulled. You can go back here, you can run it. Wait for the URL to appear. And then we can just write the what's your dream again. So this one. So now it is there, so we can just write what's your dream. Then it should load the model faster this time, since it has it into the disk. So yeah, I'm going to cut the video and come back when it finishes or crashes. So see you then. So I got another error that is called maxSecLen, and yeah, make sure that it is the correct one, which is max sequence length and not len. So we can just git add, git commit, git push, and yeah, I think afterwards it's going to have the training, the safe pre-trained, everything should be working fine. But yeah, I'm going to try again, so you can go back here, stop this, go back up, then get pull, then go back down, then go back down, and write the run this again, wait for the URL to appear, just copy this, paste it right in, right here, what's your dream, then press enter, it is running, and yeah, I'm going to cut the video again and come back when it's done. So one more edit before it's now done. Here it was just the string, which is the system prompt like this. Just add it as a dictionary and add the role equals system and add the content. I forgot to add this. So if you add it and save it and push again and pull it and run it again, and you can see here that the output is now done. So yeah, this is the character chatbot, and right now you learned how to create your own character chatbot on whatever task you want. And we have used also one of the state-of-the-art models, and it's also a big one, so that is a huge plus for us, and it's very good to put Llama in your CV. And yeah, so in this project you have learned a lot. So you have learned a lot about theme classification, character network, and text classification. So I'm going to recap them. I'm just going to put the themes again and make sure that everything is working for you guys. So for the theme classification, just copy paste the themes like this and say that we have a safe path that is in the stubs right here. So make sure to use it. Yeah, so we didn't push the stubs, so we can do so. Actually, let's upload them for right now, and I'm going to push the stubs for you when I have the chance. So I am going to try and push the stubs and also the data to the GitHub so that you can conveniently download them and find them. Because last time people had trouble finding it on Kaggle. So they have been uploaded, so you can just have the theme classifier output, just copy its path, put it right here, press this, and for the NER path, you can just copy this, put it right here, and wait for the text classification to finish. And also let's go to our model right there, add the Jutsu classifier, just copy this. Also note that after training, right there, after training here, we have a new model that is called Naruto Llama 3B_2, and I'm going to remove this and only keep the one that I originally made. But yeah, so the model was also pushed to the models right there, and I am also going to edit it in the Gradio, where it reads from the not_2 but from the normal model. So I'm going to remove this and push it to the GitHub. And yeah, so those actually models are not personal. I think they're public, so everyone can use them. So you can go ahead and use them if you want. And yeah, go back again to your visualization. You can see here that the theme classifier is already done. Run the character network. And the model path is the jutsu classifier. Let's also get the Rasengan description like we did before. So like this. Make sure that the character network is good. So yeah, that is good. Classify the text. So yeah, so that is beautiful. So everything now is working fine. So we started off by crawling our own data set from the Narutopedia fandom website. And we used Spacy for that, which is a good tool to have in your CV. And then we learned a lot about neural networks and the evolution of NLP. Then we started with the theme classifier, and we learned a lot about zero-shot classifications. And we created our own zero-shot classifier and ran it on all the subtitles and saved the results. We also have the character network, so we used NER, and we used a very good library called Spacy, and in between we used a library called NLTK to use sentence tokenizer and to use other functions as well. Those two libraries are very important when it comes to NLP. And afterwards we trained our own LLM, and we used here another model that is called Distilbert. So we gave it any text, and it was able to classify it into 3 classes, which is ninjutsu, genjutsu, and taijutsu. And afterwards, we created our own chatbot, and we now can run our own chatbot, and we can actually have it like produce more conversation, and we can ask it more things. And yeah. So that is the project. If you made it this far, then congratulations. You learned a lot about NLP, and you are more than qualified to land a mid-level NLP job. And this project is a beast, so make sure to add it in your CV. And you can also add it like in 3 different or 4 different projects together. Like have it 4 different projects if you want, or just put it into one big project. All those skills that you have learned in this tutorial are very, very important for NLP and in AI in general. So make sure to add them out. The only thing that is left for NLP right now, like you learned a lot. You learned about classification, zero-shot classifiers, chatbots, and also NERs. So the only thing that is popular that is in my head right now is using ChatGPT's API. And if you haven't done this already, I have a tutorial online on YouTube that is also using ChatGPT for text classification. You can find it. I think it's a quick tutorial, like 20 minutes. So if you do that, then you have a full arsenal that you can utilize for NLP. And most employers will only look for those skills. So congratulations again on that. And yeah, see you in the next tutorial. Have a wonderful day.